areas with regards to defense. And then after that, we'll move on to our next chapter, that is IT and communication. So these are the two things that we are going to discuss today. Defense is a very small chapter, but IT and communication, on the other hand, is a very big chapter. So it might take the entire class today, and it will also spill over to tomorrow's class. So this is basically what we are going to do in today's class. Now, the very first thing with regards to defense, something that I told you about health and diseases as well, that these are chapters that are important more from your uh, current affairs perspective. Whenever the questions come, they have come on the basis of current affairs, and you'll see something similar being followed in the future also. So in the past also we have seen the same, in the future also we expect the same, that if a question at all comes from the perspective of defense, it will be based on current affairs. Now, one thing that becomes very, very crucial from the perspective of this chapter is to understand how to read this chapter and what are your sources. Now, one of the most important sources that I believe in this chapter is the DRDO newsletter. Now, there is this DRDO newsletter, which is a monthly newsletter. All right, this is something that is published monthly, and it is available on DRDO website. This is available on DRDO website. So that's why it is something that you can access from there. The PDFs are available. The PDFs are available and downloadable every month. Now, just understand how basically you have to read this. So when it comes to this DRDO newsletter, often it will be of 20 to 25 pages. All right, 20-25 pages, out of which the second half of the magazine often is about everything that is happening at DRDO. It's more at an organization level, that this event happened, that event happened, something, let's say, some kind of event that they organized in their Bangalore headquarters, or maybe some other office somewhere in Delhi or anywhere. So these kind of things are there in the second half of this newsletter, and that's completely not important for you. All right, that's the part that you can completely leave out. But the first half, which is not more than 3 to 4 pages in most of the cases, every month hardly 3 to 4 pages, this is where everything new with regards to defense in India will be published in this newsletter. All right, so this newsletter from that perspective becomes important, because all the most important news articles with regards to defense in India will be present here in this particular newsletter. All right, so that's why I would suggest that this is something that you should keep updating yourself with every month, especially between, I would say, September of 2023 until April of 2024. So in this entire period, the newsletter, whatever the newsletter covers, please make sure that you just go through it once. It will give you an idea about everything new and important with regards to defense in India. Otherwise, often it's very easy to miss kind of articles in the newspaper when it comes to defense. So that's why from defense perspective, this newsletter is something that I would say is very, very important for you. All right, so, and just the PDF, no need to even think of hard copies. You'll not get the hard copies unless you are an employee of DRDO. You'll not have an access to this hard copy. So it's only on the website that you can get this DRDO newsletter. And so something like this, so for example, let's say uh, this is something that I've taken from the November 2023 magazine, the newsletter basically. So here what we saw was that this time they had given this as the cover story about the Sagar Dhwani mission. So when it comes to Swagar Dhwani Maitri mission, what exactly it is, everything was given there in this particular article. Similarly, every month you will see that there are 3-4 important articles that will be published here. So just to tell you, just to uh, tell you about what needs to be done. So I'm just writing it here itself so that you don't forget. Between September 2023 until April of 2024. This is the time period that you should consider for DRDO newsletter. All right. So, and largely you will see that the questions that come, the questions always have come on the basis of current affairs. Even in 2023, there was a question that was asked in your prelims examination. We'll discuss that later. And you'll see that that also was asked mainly because of current affairs. The reason why they asked that question also was current affairs. And this is something that will happen here always. Now, most important topic when it comes to defense is missiles. Now, one thing again, just a caution when it comes to this chapter. What happens is, and this is a tendency that I've seen with a lot of aspirants, that you just keep going on about reading each and everything that you can get in defense. That you make a list of all the missiles that India has, all the aircrafts that India has, all the helicopters. See, practically, it's not feasible, first of all, that you, even if you think that you will be able to learn about each and everything, that's not possible. And even if you, let's say, are a superhuman and you are able to do that, even then we are not even expecting a question to come from everything. We are expecting that questions will be based on current affairs. Questions will be, and you just go and look upon all last 15, 20 years of every defense based question that they have asked, you'll find that questions always have come on the basis of current affairs only. So that's why doing this extra bit does not serve you any purpose. So that's why try to restrict yourself in this manner. Otherwise, I mean, why do you think that you only have to read about missiles and you only have to expect the questions to come from missiles? There are different types of missiles that India has. Easily there are 50 plus kinds of missiles. Then there are different types of aircrafts, there are different types of helicopters, there are different types of submarines, there are different types of navy ships, there are so many different types of tanks that India has. Forget about everything, there are different types of bullets that India has. So you cannot just go and keep reading about the properties of each and everything. Just the things that are in the news, just try to restrict yourself to that, and please don't go beyond that, because it will just waste your time, and it's not going to serve you any purpose in your examination. So please make sure that you do not just keep doing this and waste time on this, because it's not even that every year a question comes from here. You'll see that questions have been coming every second year, every third year, or something like that. It's not even that they have been asking questions every year. So then it's not something that is giving you a good output, that you should be reading each and everything here. So restrict yourself. Now, important topic wise, I would say that missiles always would be the most important topic for examination, because this is the most discussed part of defense. Most of the cases, this is the most discussed part. So that's why missiles become important. Now, when it comes to a missile, a basic understanding of what do we mean by a missile. Now, missile, typically you would know that a missile looks like this, right? A missile looks like this and has a very similar structure to how we discussed, uh, what we discussed about space technology. So in space technology also we discussed that there is something called as a payload. So something similar here also, this part is called as the payload. So you have the payload like this, and then after this, this payload here is basically also called as warhead. This payload is also called as warhead. Now, why we call it as a warhead is mainly because this is where all the explosives will be present. Any kind of explosive. It could be a chemical explosive, it could be a biological explosive, it could be a nuclear explosive, it could be anything. And the rest of the part is just like the launch vehicle. So this is same as what we discussed in case of our space vehicles as well, that this part is the launcher, and then you have the payload here. Now in this particular scenario, when it comes to any given missile, there are different ways in which we classify the missiles. And how do we classify is also something that is important, because whenever questions come, if at all questions come, they will ask you something based on these kind of classifications. These are different ways in which we classify. So first way to classify the missiles is on the basis of the range of the missile. Now, on the basis of the range, what we have is we have short range missiles, intermediate range missiles, long range missiles, and intercontinental missiles. Now, this is based on the distance that they are going to cover. That's why the range, it's based on the range. So if it is just going to travel, let's say 50 kilometers or 100 kilometers, then in that case we say that these are short range missiles. Similarly, intermediate range missiles largely up to 1000 kilometers. Then long range missiles can go up to 2500 kilometers. And most of the times when you have missiles that can go beyond 2000 or 2500 kilometers, then in that case we call them as intercontinental missiles, because they can travel from one continent to another. That's why intercontinental missile. Now just remember that there is no fixed demarcation, that only up to 100 will say that it is short range, and beyond 100 will start saying that it is intermediate, and so on. There is no clear cut demarcation. All right, no clear cut demarcation. So that's why on the basis of range, when we are looking at things, we see that there are all these different types of missiles. So that's what we see on the basis of range. Then on the basis of the start and the end point. Now this basically is whether it is starting from surface and going in the air, then in that case we'll say that it is surface to air missile. Similarly, if it is starting from air, meaning that let's say you are using an aircraft or a helicopter to launch the missile, we'll say that it is starting from air. And maybe if it is going to strike something in the air, then it will be called as air to air missile. So on the basis of the start and the end point, we can have surface to surface, surface to air to air, or air to surface kind of missiles. So in this manner we see that this is how we classify the missiles. Then on the basis of trajectory, now this is the most important classification of a missile is on the basis of the trajectory. What kind of trajectory do they take? So on that basis we have ballistic and cruise missiles. Ballistic missiles and cruise missiles. So just try to understand first, what do we mean by a ballistic missile versus a cruise missile. Now if you see this, in case of ballistic missile, you can see that it has a parabolic path. It is just like you having a ball and you throwing a ball. So when you throw a ball, then the kind of trajectory that the ball would take is the parabolic path. So something similar happens with ballistic missiles also, that ballistic missiles also will have a very similar path. All right. When it comes to the cruise missiles, on the other hand, cruise missiles are different. Cruise missiles are more like airplanes, where they'll fly like airplanes and their path can be controlled like airplanes. And that's not the case with the ballistic missiles. So that is where they are basically different on the basis of their trajectory. That one, there is one missile, ballistic missile, that takes a parabolic trajectory. On the other hand, we have the cruise missiles which take an airplane like trajectory. So that's the basic difference between the trajectories of ballistic and the cruise missiles. So on that basis we see that this is how we classify, and this is the most important classification of a missile. So on one hand we have ballistic missiles, and on the other hand we have the cruise missiles. Ballistic and the cruise missiles. So the first difference is that in case of ballistic missiles, we know that it takes a parabolic path, right? It takes parabolic path. On the other hand, we have cruise missiles which have a path similar to airplanes. So airplane like path. Airplane like path. So that's the first difference between the two. So now, because of this kind of difference, what happens is that when it comes to a ballistic missile, we preset the target. In most of the cases, we'll preset the target. So we already have determined that this is where we want to strike. So it will be pre-logged and then it will be sent. In this manner, we actually can achieve a higher distance or a higher range. So that's why it has a higher range. So all the long range missiles, intercontinental missiles, etc., they will all be ballistic in nature, because you've prefixed the target and then you just launch it. Whereas since we have a controlled path in this particular scenario, because we have a controlled path, that's why we see that the range here will be shorter. Grammatically writing higher range is wrong. It's longer range. Longer range and shorter range. So this is the second difference. Now the third difference is on the basis of their destructive capacity. Now again, it goes to the same thing, that because ballistic missiles, they have a prefixed path and everything is fixed, we can provide a good amount of thrust to it, and it can deliver much more destructive power as compared to cruise missiles. So that's why here we see that it has higher destructive power, higher destructive capacity. And in case of cruise missiles, they have lower destructive capacity. Right now, so there are all these things that we see. Apart from that, one more thing that adds to, I would say, the advantage of ballistic missiles, that they generally travel at faster pace, or they have higher speed. So they have higher speed, whereas in case of cruise missiles, they have lower speed. Now you might think that if this is the case, then ballistic missile is a better missile compared to cruise missiles. So why do we even have cruise missiles? Why do we even need cruise missiles? Because we see that long range is there with ballistic missiles, better destructive capacity ballistic missiles, higher speed ballistic missiles. Then in that case, what is the advantage with cruise missiles? Why do we even need a cruise missile? Can you think of the answer? Yes, Nikki, you are correct. Sai Dinesh, you are correct. Accuracy is where you need cruise missiles. All right. So it has lower accuracy. Ballistic missiles have lower accuracy, whereas cruise missiles have higher accuracy. That is where you need cruise missiles. When you want to be more accurate, when you want a higher precision, this is where you need cruise missiles. Otherwise, if you need higher destructive power, you want longer range, or you want faster speeds, then in that case ballistic missiles would be the choice. So that's why we have both the kinds of missiles. That's why we develop both the kinds of missiles, depending on our requirement, depending on what we want out of that missile. We see that there are different types of missiles that India has. Now, so it's about the path. Ballistic missile basically taking a parabolic path, whereas in case of cruise missiles, we see that it is a controlled path, and many times it becomes very even difficult to detect a cruise missiles as compared to ballistic missiles, because cruise missiles can actually also sometimes uh, fool the radar system as well, and radar may not be able to detect the cruise missiles. So that those kind of missiles are also available, although even in ballistic missiles today we have been able to achieve these kind of scenarios. So I wouldn't say that it is something that exclusively lies with only one category and does not lie with the second category. But most importantly, accuracy is where cruise missiles takes over ballistic missile. Now, there's one more classification, and that's the basis of their utility. We have strategic and tactical missiles. Now, tactical missiles are the missiles that we use in a battlefield, something that can be used during a war. something largely that can be used during a war. Now, in these kind of scenarios, when it comes to tactical missile usage, here accuracy requirements will be higher, ranges requirement perhaps will be lower. So these could also be anti-tank missiles or missiles that you are going to use in a long shorter range with higher accuracy. So in these kind of cases, that's why we generally see that tactical missiles generally are cruise missiles. All right, so during a war, so that's why they are short distance, short range, short range, and high accuracy. So we basically see short range and high accuracy. So that's why generally they are cruise missiles. Generally, these would be cruise missiles. On the other hand, when it comes to the strategic missiles, these are missiles which are strategically important for a country. All right, strategically important for a country. Now, what I mean by strategically important is that these kind of missiles perhaps will never be used by a country. These could be nuclear powered missiles, high destructive capacity missiles, missiles that can travel 5,000 kilometers and so on. So these kind of missiles are, you can say, more of show off, that these are missiles which we just want the world to know that look, we have these missiles. So if you are going to do something against us, we have the answer. And that's the reason, you can say, most of the times when it comes to strategic missiles, that this is where you have these missiles to show off, just to let everybody know that look, I have this missile. So whether you are going to use it or not, perhaps never, maybe never, these kind of missiles will be used specifically by India, and I hope so, that these missiles are never to be used. But at all, if it comes to it, it just to show everyone that we have these missiles. And that's why we see that strategic missiles also give us the second strike capacity. They basically give us something called as the second strike capacity. So when it comes to the second strike capability, this is a capability to strike after being struck. All right, this is the ability to strike after being attacked. Now, what do I mean? In this particular scenario, when it comes to the second strike capacity, this is where these are missiles which often will be kept at strategic locations, unknown locations, sometimes with submarines, etc., so that they can be launched back if at all we already have been attacked. If somebody has tried to attack us on our very strategic positions and etc., then in these cases, these kind of missiles will be ready to attack back, to uh, to attack the enemy whenever these kind of scenarios have happened. So that's why strategic missiles are, in most of the cases, this scenario. So we see that these are generally long range, highly destructive, long range, highly destructive missiles, and these are generally ballistic missiles. These are generally ballistic missiles. All right, so this is basically how we are looking at all these missiles. So this is how we classify. Now this classification is important because many a times when the questions come, they would ask you something based on these classifications, that they'll name the missile, and they might want to confuse you between whether you know or not that it's a ballistic missile or a cruise missile, short range missile or a long range missile, surface to surface missile or surface to air missile. So these kind of things they can do, and they have done it in the past. So that's why you have to be ready from that perspective, that they might ask you a question from current affairs. They'll always pick the question from current affairs. Just that these things, I mean, whenever you come across any missile name, let's say there is any missile that is being tested, so whenever the missile is being tested, you just go through all the details related to this missile. All right, and especially on the basis of these four brackets of classification that we just discussed. So if you do that, you'll see that questions many a times will come from here, and you'll be then able to answer this better. You'll be in a position to answer this in a much better fashion. So that's why you have to understand that these are how we classify the missiles. Now, when it comes to the Indian missiles, we see that we first started with something which is called as the Integrated Guided Missile Development Program. We started with the Integrated Guided Missile Development Program, and this program became important because this is where, for the first time, we started working on our missile programs. And this was 1983. This was the year 1983 under the Prime Ministership of Indira Gandhi. This is where we started working on our defense program, and it took us some time, almost you can say almost like next 15-20 years, and we were able to develop all these missile systems. So there are five types of missiles. There are five types of missiles that we developed under this program. Can you name them? Can you name the five types of missiles? Yes, Agni is one of them, correct. Trishul, correct. Prithvi, correct. Hmm. Varsha, you have given the correct list. So that's, so yeah. So many of you have given the correct answer. That's great. So five names. I mean, to remember the five names, you can use the beloved city of Patna. We have Prithvi. We have Agni. Then we have Trishul. We have Nag. And we have Akash. These are the five families of missiles that we developed as a part of the Integrated Guided Missile Development Program. So in this manner, we see that this is how we started working on it, and each and every one of these missiles had a speciality. These are all different types of missiles that we started developing. So keeping one part of our defense program in mind, one kind of missile family was being developed. So in this manner, we see that these are the five types of missiles that we developed as a part of Integrated Guided Missile Development Program. So we started developing it, and for the next 20-25 odd years, you can say that we just kept on developing all these missiles, and newer versions of these missiles also from time to time are being released. For example, last year, very much in the news has been Agni 5 missile, the fifth Agni missile that has been now tested by India completely successfully. And it's not that for the first time uh, it was done. I mean, it was done last year, because when it comes to Agni 5 missile, the testing of Agni 5 missiles have been happening for a while, but they all have been pretty successful. So that is where they now are considering that soon it will also be a part of the Indian arsenal. So a lot of different types of tests have happened. A lot of test firing has happened with Agni 5 missiles. Now this Agni 5 missile was last year in the news, and that's why this year in your prelims examination, one question actually was asked based on Agni 5. Before this, in 2014, they had asked an Agni 4 missile question, and that is when Agni 4 was test fired, and that is why a question was asked in your prelims examination. So that is why I was saying that these kind of questions often come when these systems are in news for one reason or the other. So, so as a part of the Integrated Guided Missile Development Program, we developed these five families of missiles. Now, there are other missiles also. Many of you wrote about BrahMos, but BrahMos is not a part of the Integrated Guided Missile Development Program. BrahMos is a different program that India took up. And this, when it comes to BrahMos, BrahMos is a cruise missile. BrahMos is a cruise missile. We say that it is a supersonic cruise missile. Supersonic meaning that it travels at a speed which is above the speed of sound. Now, this is very unique for a cruise missile, because what we discussed is that cruise missiles have lower speed as compared to all the ballistic missiles. So, ballistic missiles inherently are supersonic, But cruise missiles in many cases, in most of the cases, are not. BrahMos missile is the world's fastest cruise missile. It has become the world's fastest cruise missile, and we are right now with the supersonic speed of Mach 2.8 and range of up to 290 kilometers. Now, in this particular scenario, when it comes to the BrahMos missile, there was a restriction that we originally had, that we were not allowed to go beyond the speed of Mach 3 or beyond the range of 300 kilometers. All right. So we were not allowed to do that. And that is where we saw that BrahMos missile could not go there because we were not a part of MTCR, or Missile Technology Control Regime. So India originally was not a part of MTCR, and that is why these restrictions were put, that we couldn't go beyond this range. But then we became a part of MTCR. We also became a part of the Missile Technology Control Regime, and that is where we see that, so these were the BrahMos missiles that we have uh, tested. Then after that, BrahMos 2 missile came into the picture once we became a part of MTCR. So that's when now the range is expected to be up to 450 kilometers, whereas a maximum speed that BrahMos 2 could reach potentially is up to max 7. Now, this is basically a big jump, and it's not that easy. At the same time, scramjet engine will be used here. Scramjet engine will be used for BrahMos 2. So if you remember, we discussed about scramjet engine in our space technology lecture, correct? That is where we had discussed it, and we discussed how it could use air from outside instead of carrying oxidizers. So similarly, in case of BrahMos 2 also, this same scramjet technology that has been developed by ISRO will be actually used by DRDO in these uh, missiles. So that's why it becomes very crucial from that perspective. And this is basically a version of a scaled down version of BrahMos 2. This is how it is supposed to look like. Then after that, we also have Indian Ballistic Missile Development Program. Now, as a part of this program, this is more of a defense initiative. All right. This is not an offensive initiative, it is a defensive initiative, because in most of the cases, we are talking about missiles that will go and attack. It will attack somebody. But these are missiles which are supposed to defend. These are missiles that will help us in making a multi-layered ballistic missile defense system, so that we can protect ourselves from ballistic missile attack. So ballistic missiles often are, because they are very quick, they are very fast, and they can be highly destructive. It would be very difficult for us to respond to any potential attack of ballistic missiles. Compared to that, responding to cruise missile attack could be still a possibility, because cruise missiles travel a much more at a much slower pace as compared to the ballistic missiles. So that's why this was required. And what India did is that we made a multi-layered uh, defense system, where we basically have two systems. One is the Prithvi air defense, and the second one called as the advanced air defense. Prithvi air defense and advanced air defense. So in case of Prithvi air defense, this basically is required for high altitude intersection, that is exo-atmospheric range, meaning that we are going in above the atmosphere, or we are going towards the higher part of the atmosphere. Whereas we have the advanced air defense, which is meant for low altitude intersection, meaning for the endo-atmospheric range. So in this manner, we see that we have Prithvi air defense and we have advanced air defense. So one is meant for the higher part of the atmosphere, and the second one is meant for the lower part of the atmosphere. So in this manner, we are now working on this multi-layered system when it comes to the defense program. There is another this missile that was also launched. AD-1 missile was launched a couple of years back, tested rather, a couple of years back, and that also is a part of this entire defense mechanism that we are working with. So in this manner, we see that there are multiple ways in which we are trying to also not only make missiles which are offensive in nature, but we are also working on missiles that can be defensive in nature and save us against any potential attack from outside. Then one more thing that has been in the news on and off are Indian radars. Now, in case of radar, we know that it is an acronym for radio detection and ranging. But when it comes to radars, just understand the basics of how a radar system works. So something like this, just understand this diagram, it will make it easier for you. So basically what happens is that there will be an antenna like this, right? And in any radar system, there will be a transmitter and there will be a receiver. Transmitter will do what? Transmitter would transmit waves. What waves? Radio waves and infrared waves. All right, radio waves, sorry, and microwaves. Radio waves and microwaves. So they would use radio waves and microwaves, and they will just transmit these waves. Now these waves, once transmitted, if let's say there is any incoming aircraft or any incoming missile, these waves will go and collide with them and reflect off their surface. So once they reflect back from their surface, they will be received, right? They will be received by the receiver that we have as a part of this entire system. So in this manner, you will have the transmitter and the receiver. Receiver will receive the signal, and based on this receiving of our signal, this is how we decide about or understand about the incoming aircraft of the or the missile. So for example, we know that when it comes to these waveforms, their speed is fixed. They are electromagnetic waves, so their speed is fixed. Speed is fixed. We know the time it took for it to go and reflect back. So we know the total time that it took. So we know the distance. Sorry, we know the speed, we know the time. So we can calculate the distance. And in this manner, we'll be able to calculate the path, or we'll be able to understand the path that this kind of a system is taking. So in this manner, we'll see that there are all these scenarios that are coming into the picture. So this is how any radar system works. And when it comes to the radars in India, today we have different types of radars. There are some radars which are being used along with the missile systems. For example, the Akash missiles that we discussed as a part of integrated guided missile development program. Akash missiles are also fitted with radars. At the same time, there are different types of radars that India has developed for various different purposes. So this is how a typical radar system would work, that you would have a transmitter and a receiver. Transmitter will basically transmit radio and microwaves. Radio and microwaves. So they would transmit it and receiver would receive back the signal. Depending on the time that it has taken to receive the signal, the distance can be distance can be calculated, or the path can be calculated. The path can be understood of the incoming missile or the aircraft. So this is basically how we work with this. Now lastly, today we have a technology which is called as stealth technology. A lot of new age uh, aircrafts, or especially the fighter jets that are now coming in, you'll find that these fighter jets, they basically are fighter jets which are fitted with the stealth technology. And if they are fitted with stealth technology, it means that they would be able to bypass radars. Radars will not be able to uh, control their path or understand their path well, and they'll be hidden from the radars. So that kind of technology is called as the stealth technology. Now, when it comes to the stealth technology, we see that there are multiple different things that are used to make sure that the stealth works. So if you look at any system like this, any aircraft like this, which has stealth technology in it, if you observe this picture, what you'll see is that it has very sharp and flat surfaces, right? It has very sharp and flat surfaces, and at the same time the color that has been used is black, right? Or almost very very dark color. So either very dark colors or completely black in color they would be. First, second, they would have flat surfaces. Third, they would have very sharp edges. And fourth, they'll be made of material, and we'll use certain materials which can also absorb waveforms. So we'll try to do that. So overall, we see that there are all these mechanisms that we employ to ensure that this kind of a fighter aircraft can uh, bypass a radar, and it will just fly low without even being detected by any radar system. So that's why we see that there are all these things that become very, very crucial. So when the waves basically will go and hit their surface, they will be reflected in various different directions. They will be reflected in various directions instead of just coming back and be received by the receiver. So that is where we'll see that this will be a different kind of an aircraft which will be able to do all this. So what all? First and foremost, we'll see that they would have flat surfaces, sharp edges, black or very dark color, and material to absorb waveforms. All right. So this is what we'll see with these kind of stealth aircrafts. So generally you'll see that all the fifth generation aircrafts that have now started coming in, these fifth generation aircrafts, they essentially have the stealth technology inbuilt in them. So this is basically just a basics of what you see with regards to defense. And as I told you that the questions that we are expecting from this particular chapter has to be based on all the current affairs that you might come across in the coming months. So that's why September 2023 to until April 2024, this is the time period that you should be very safe with, and every news article with regards to defense in India, you should just keep reading. So any questions with regards to whatever we discussed? Anything that you want to ask? Difference between antenna and radar. See, radar system is a much bigger system, right? Radar system is a much bigger system, and antennas are just a part of it. You would have antennas in this radar so that it can just collect all these waves, all the reflected waves, and antennas will also help in the transmission of the waves. But after that there will be the decision making unit also, and decision making unit will ensure that it can calculate and comprehend all the things that they have received, the signals that they have received with the help of the antenna. Mainly because the static part of the chapter is not relevant for the examination, and that's why it would be unnecessary if we go through other things. So that's why you have to base it more on your current affairs. Edition, I mean, it's not that every monthly edition will have everything important. Something has to happen which they should be able to report. So that depends. I mean, every month the things could be different, but this month I think November issue was important. Generation, as we call it, the Rafale jets that we have bought. So partially it does have stealth, but it does not have as effective stealth as the fifth generation aircrafts have. But we are developing it. We are developing it, and will Tejas, for example, Tejas will have stealth in it. So that's why we'll see that India will soon also have it. What's the objective of MTCR? MTCR stands for Missile Technology Control Regime. So basically, it tries to ensure that all the different types of weapons, especially the missile-based weapons that are there in the world, they can be regulated well. What's exo and endo atmospheric? Exo atmospheric is when you are, exo means what? When you are exiting. So that is what exo is. So exo means the higher part of the atmosphere. Endo means the lower part of the atmosphere, which is near the earth. Patna missile. There is no Patna missiles. I told you that you have to read the things, listen to things carefully. These are Prithvi, Agni, Trishul, Nag, and Akash. I told you to remember them better. It's an acronym that you can use to remember the things. Discuss different generations of aircrafts. Not required for your examination. You can skip it. BrahMos is a ballistic. No, BrahMos is a cruise missile. That's why I told you that BrahMos is a cruise missile and the fastest cruise missile of the world. Can we expect mains question from this chapter? I would say generally no. I mean, until now, in last 20 years, there is just one question that has come in the mains examination from this chapter, because it was based on S400. So apart from that, we see that chances of a question coming, even that question that they asked was more of a prelims topic, but they just asked it in the mains examination. Otherwise, we'll be expecting questions to come in the prelims more. All right. Yeah. So coming to the next chapter, that is IT and communication. Now, this is a chapter which again I would say is more important for your prelims perspective. If you look at the question papers, you'll see that almost again every year one question or sometimes two or three questions also have been coming, and especially in the last 5 7 years, uh, the questions have been coming even more often compared to what they used to. So that's why IT and communication as a chapter now becomes very very important, and especially in the, you can say, the era of digital communication, and as digital communication started to take up bigger markets, this is where we saw that the number of questions coming from this chapter also started to increase now, and that's why we'll be in uh, expecting that in prelims examination the questions could come from here. All right, in prelims examination the questions could come from here. So that's why its focus also is more on that, but it's not that we can't say that questions will not come in mains. That goes without saying for anything. So we'll also see some of the aspects of what they can ask potentially, if they can, what can they ask in your mains examination, but largely we'll see it from prelims perspective. Now a chapter this is a chapter where you'll see that the chapter is very different also with regards to many of the other chapters, where there are a lot of small topics and all these topics are independent of each other, whereas in other chapters until now we saw that there was a continuation of whatever we were discussing. So that's how it is also different, that you'll see that each and every topic is completely independent of the other topic and has no relation with your understanding of another topic. So we'll discuss about various forms of wireless communication, what is Bluetooth, what is Wi-Fi, what is 5G. All these things we'll discuss. What is Internet of Things, what is quantum computing, which has started becoming very crucial now, what are supercomputers, what is Internet of Things. So there are all these kind of topics that we are going to discuss in today's class, I mean as a part of this particular chapter. Now in this chapter, when it comes to IT and communication, when it comes to this chapter, first and foremost, the first part will be about wireless communication. Different forms of wireless communication is what we'll discuss as a part of this part. Now, when it comes to wireless communication, first and foremost, wireless communication means what? That you are not going to use wires, right? You are not going to use wires for your communication. Hence, you are calling it as wireless communication. Now, in this particular scenario, when it comes to wireless communication, meaning that the transmission and the reception has to happen without using wires. For example, your mobile phones, where you don't use wires, right? You can communicate, you don't use wires. So that kind of communication is called as wireless communication. Now, how do we implement wireless communication? What do we use? Where in science do we find the courage to implement wireless communication? And that basically comes from electromagnetic waves. Wireless communication is based on electromagnetic waves. Now, understand some of the important properties of electromagnetic waves. That why are we using electromagnetic waves here? Now, when it comes to electromagnetic waves, there are certain properties that become essentially important for electromagnetic waves. So, for example, let's say if a question pops up in your mind, that why are we using electromagnetic waves? Can we use sound waves for communication? Can we use sound waves for wireless communication? And if not, why don't we use sound waves for wireless communication? So there are all these basics that you should understand, that why exactly do we prefer, or why do we exclusively, not even preference, uh, why do we exclusively use electromagnetic waves for wireless communication, and why don't we use something else? All right, so we'll try to understand this part. So when it comes to, first and foremost, when it comes to electromagnetic waves, the speed of electromagnetic waves is very fast. All right, so first thing, very very crucial, that they have very fast speed, very high speed. On the other hand, a very very important property also is that they are independent of any medium. It doesn't matter whether they are traveling in air, whether they are traveling in water, whether they are traveling on a solid, or whether they are traveling in vacuum. Wherever they travel, they would always maintain uniformity in their properties. So they would not change their properties from one medium to another. They'll not change their speed from one medium to another. So for example, light is an example of electromagnetic wave. So light from sunlight, you know that sunlight is basically a light form, light that we can actually comprehend. So that light starts from the sun and reaches the earth. Correct, starts from the sun and reaches the earth, and takes around 8 minutes to do that. 8 minutes and 19 seconds to be exact. So it takes almost 8 minutes to do that. And this, between the sun and the earth, there is no medium, there is no air there. All right, air that we have as a part of our atmosphere, after the atmosphere, that air ceases to exist. So you have a vacuum. Vacuum is the place where you have no medium. That place is called as vacuum. So there is a vacuum that you have between the sun and the earth. Light rays still travel, then it comes to the air, through the atmosphere, still reaches the earth's surface. So that's why when it comes to electromagnetic waves, there are two things that become very crucial. That first and foremost, they are very fast. They are very fast. For example, we know the speed of light. So that is how they travel. 3 into 10 to the power of 8 meters per second is the speed at which they can travel. And they are independent of medium. Independent of medium. So it doesn't matter what medium they are traveling through, they would always be able to travel with the same properties, with the same speed and everything. So that is how we see that electromagnetic waves become important. On the other hand, let's say if somebody wanted to use sound. Now sound is not an electromagnetic wave. Sound, first and foremost, travels at a much lower speed. Much lower speed of the sound can be, in general, approximately 340 meters per second. So speed is very very slow compared to the speed of light. And at the same time, it is dependent on medium. The speed is dependent on medium, or its even properties dependent on the medium. So that's why using sound is not feasible for us when we want the message to flow, or the communication to flow through satellites that are placed at almost 36,000 kilometers, right? So that's why, that is where we see that electromagnetic waves become very very crucial, and that's why we do not generally prefer when it comes to all these different types of communication that we have built. Theoretically, is it possible to use sound? Yes, it is, but with a lot of restrictions. So that's why would we build a system which is built on a lot of restrictions? So that's why we don't use it. But there are properties of sound that can be used. For example, sonar is where you use the properties of sound for establishing some form of communication. But largely when it comes to electromagnetic waves, we see that electromagnetic waves, because of the kind of independence that it gives you, the kinds of versatility that it gives you, you will be able to use them much better as compared to anything else. So that's why electromagnetic waves are preferred and not the sound waves. So now when it comes to the electromagnetic waves, uh, what happens is that they do not need a medium. All right, they do not need a medium, and they can travel. Sound cannot. Sound would need a medium. So for example, even if my voice is reaching you, there is a reason for that. That whatever I say, when I say it, there are air molecules that I have around my mouth. So what happens is that these air molecules will start to vibrate, and they will just collide with one another, and they'll keep on passing the information to a mic which is fixed right here. So because of air that we have between my mouth and the mic, we'll see that this sound will travel. And then from the other hand, you have the microphone, and through microphone the same sound will travel through your to your ears. If let's say we were living in a vacuum, suppose that a studio where I'm taking the classroom, if it was vacuum, then in that case whatever I say will never reach you, because there is no medium for this sound to travel. So even if I say something, it will be like when I'm put on mute, that when I keep saying something but you will never understand what I'm saying. All right, so it will be that kind of a scenario. So this is where we see that electromagnetic waves become very, very special. Words or terms that we'll keep using all throughout this chapter: wavelength and frequency. What is the meaning of wavelength and what is the meaning of frequency? So first term is wavelength. Now wavelength is what? Wavelength meaning length of the wave. How do we understand what is the wavelength? We basically look at two similar points and the distance between two similar points, that will be called as the wavelength. So for example, if I start here and I go all the way down, come all the way up, come back to the similar point, this will be called as the wavelength. Similarly, if I want, I can start here. I start here, I go all the way down, all the way up, back to the same point. This will be called as the wavelength. So that's why when you start from a point and you reach this exact same point, then in that case, it will be called as the wavelength of that wave. So length of the wave. Now, as you can see here, that wavelengths can be short or long. If the distance is longer between two similar points, it will be a long wave. If the distance is shorter, then it will be short wave. So that's why the measuring of the wavelength will be done in meters or maybe fractions of meters, right? Either meter or fraction of a meter. This is how we'll do it. So wavelength. So on one hand, we have wavelength like this. On the other hand, when it comes to the frequency, another term which is also often related to wavelength, frequency is about how many waves pass through a given space in a given unit of time. Meaning that let's say starting from here, all right, let's say starting from here and going up to here. Let's say if we say that this is 1 second time, this is 1 second of time period, then between A and B, let's say if I'm calling this as A and I'm calling this as B, if I ask you between A and B, how many waves do you see in that 1 second in A? How many waves do you see in that 1 second in A? Three, correct? Three waves. How three waves? We are starting from here: one, two, and three, right? So there are three waves that you see here, correct? On the other hand, what about this? The B case, how many waves? One. Correct. So we start from here and we come back to the same point, almost the same point. So there is this one wave. Now, what you observe is that what is frequency? Frequency, we say that frequency is the number of waves that form in a given length of time. Number of waves in a given length of time. Now, as you can see that in the first case, there are three waves in 1 second, correct? Whereas in the second case, there is just one wave in that 1 second. So, when the wavelength is short, frequency is high. Frequency is high. When the wavelength is long, frequency is low. All right. So when long wave, low frequency, short wave, high frequency. Why? Simple. Because in 1 second you will be able to fit more waves. So that's why it will have higher frequency when the wavelength is short, and that's why it will have lower frequency when the wavelength is long. So this is how we calculate based on the wavelength and frequency. So that's how we look at wavelength and frequency. So in a manner, what you simply understand is that wavelength and frequency are inversely proportional, right? They are inversely proportional, meaning that if one increases, the second would decrease. If one decreases, the second would increase. So that is what we mean by inverse proportion, and that is what we see here. So wavelength and frequency, these are inversely proportional. Now, apart from wavelength and frequency, there is one more factor that becomes very crucial, and this is the factor of energy. Now, how energy is also related to this, let's try to figure that out also. So, just understand this simple relation. When you have long wavelength, when you have long wavelength, you would obviously have low frequency and you would have low energy. So energy and frequency are directly proportional. Energy and wavelength are inversely proportional, meaning that whenever you have any wave that has long wavelength, it will have low energy. All right, it will have lesser energy if it has longer wavelength. And then obviously, the opposite of it is also true, that if you have short wavelength, then you have high frequency, and you have high energy. So frequency and energy are directly proportional, and it is inversely proportional to the wavelength. Now, on this basis, first and foremost, try to understand all the different types of electromagnetic waves that we have. That what are these different types of electromagnetic waves? So first and foremost, when it comes to the electromagnetic waves, what you see right here is that there are all these different types of waves which are called as electromagnetic waves, and this is called as the spectrum of electromagnetic waves. All right, this is the spectrum. This is the spectrum. This is the spectrum of electromagnetic waves. Now, when it comes to this spectrum of electromagnetic waves, spectrum means the entire range. In a manner, you can say the entire range of electromagnetic waves. So, where here we see that there are different types of electromagnetic waves. We have the radio waves, the microwaves, the infrared, visible light, ultraviolet, X-rays, and gamma rays. So as you can see, the radio waves have the longest wavelength and gamma rays have the shortest wavelength. So gamma rays have the shortest wavelength, meaning what? They would have high energy and high frequency. And they have high energy is something that we have discussed where? Nuclear energy. That gamma rays are released because of nuclear processes, which can be very dangerous, right? health wise they can have very immense drastic effect. Discuss this. So that is basically where it comes from, because it has very short wavelength, it has very high energy, and that's why it can be extremely damaging. On the other hand, when it comes to radio waves have long wavelength, and hence they have low energy. So that's why they are relatively less harmful, very less harmful, almost they have no effect on us. So that is why we see that radio waves become more useful for us. Radio waves become more useful for us for two reasons. One, the first reason is long wavelength. Long wavelength means that they'll be able to travel longer. They'll be able to travel longer without losing a lot of energy. All right. They'll be able to travel longer without losing a lot of energy. So that's why they are effective for using in communication. That's why you'll see that most of our wireless communication is actually based on radio frequency or radio waves. Whether it is your mobile phone, your radio communication, television, internet, or anything that you can think of, Bluetooth, Wi-Fi, all these things are based largely on radio waves. Why radio waves? Radio waves have long wavelength. Long wavelength means low energy, meaning that the energy dissipation, the loss of energy will also be lesser. So that's why you'll be able to use them much more conducively. And secondly, of course, they are not harmful for us because they have low energy. On the other hand, if we wanted to use gamma, if let's say hypothetically that our mobile phones were working on gamma rays, then in that case, first and foremost, the loss of energy will be very high. So implementing this technology would be extremely difficult, and on the other hand, we'll die. Will die if we are using mobile phones that are using gamma rays, because ultimately they are going to be very damaging, and as soon as you start using them, they'll just burn off skins and tissues and have a lot of complications even if used in very tiny amount. So that's why we see that gamma rays are not useful, whereas uh, radio waves are useful. So I'll just write it also so that you remember it. Why radio waves preferred for wireless communication? The answer is that radio waves have long waves or long wavelength, so they can travel longer distance without losing a lot of energy. Hence, they are practical and cost effective. And then comes actually the more important part, that since they have low energy, they are not as harmful as the shorter wavelengths. Alright, so that is the reason why we prefer radio waves for wireless communication. Now, overall, when it comes to wireless communication, there are various different types of wireless communication. But before going there, let's also have a basic, quick understanding of all the different types of electromagnetic waves. Now, if at all a question has to come, some of the questions have been asked in the past, but if at all they have to ask a question, there are three parameters that become important for any wave that you are reading about. First one, all the wavelengths, the wavelength range of all these electromagnetic waves, they many a times have been asked in the paper. Secondly, frequency. Now frequency may not be important, frequency may not be that important, as important as the wavelength. So remembering wavelength is much crucial, much more crucial as compared to frequency. And third, the applications, where do we use them, applications. So these three parameters for any given electromagnetic wave, it becomes very, very crucial. All right. Now, in this particular scenario, when it comes to radio waves, what we basically see is that in case of radio waves, the frequencies can be up to approximately 30 gigahertz, whereas wavelengths are greater than 10 millimeters. So wavelengths greater than 10 millimeters and frequencies approximately 30 gigahertz. Where exactly do we use radio waves? Largely for communication, largely for different types of communication, different types of wireless communication is where we are making the use of them. So that is basically how the radio waves are largely used, and we'll discuss about the different types of communication that we have developed around radio waves a little later. Then we have the microwaves. Now microwaves have frequency range between 3 gigahertz up to 30 terahertz and wavelengths between 10 millimeters to 100 micrometers. 10 millimeters to 100 micrometers. And when it comes to microwaves we just discussed that we use it in where, we use it in radars, we can use it in radars. So in radar systems it can be used. It can also be used for high bandwidth communication. High bandwidth meaning, in a manner, high frequency, high frequency communication. So higher frequency, I mean, we know that radio waves have the least frequency because they have the longest wavelength, so they have the least frequency. So when you need a higher frequency range for some kind of communication, then in that case microwaves could be used. But again, it's a very, very limited way in which microwaves are largely used for these communication purposes. They will be used in other activities. For example, in radar systems we will be using microwaves. At the same time, you might have heard of microwave ovens, right? Where we can cook, or at least we can heat the food. So because when it comes to microwaves, microwaves are often also associated with heat. Wherever you have strong sources of heat, you'll find that microwaves can be detected there or can be found there. So similarly, in case of microwave ovens, we actually make the use of microwaves to generate that heat so that you can cook the food or heat the food. So that is where we see that microwaves actually can be useful. At the same time, if you remember, we discussed about something called as cosmic microwave background, right? We discussed about cosmic microwave background in space technology. So cosmic microwave background, what we discussed is that it is a background of microwaves that are visible through some instruments, and these are nothing but the heat remains of early part of the universe. So heat remains, so heat basically is showing itself as microwaves, heat is propagating as microwaves. So that's why microwaves are often associated with strong sources of heat. Wherever you have heat sources, microwaves might be present there. So that's why in case of even microwave ovens, we see that microwaves are actually being used there. So that's a heat source for microwave ovens, and even in industrial applications, we can make the use of microwaves. Then after that, we have the infrared. Now, infrared is between 30 terahertz up to 400 terahertz, wavelength between 100 micrometers to up to 740 nanometers. 100 micrometers to 740 nanometers. Now, in case of infrared, again, infrared is not visible. All these waves, they are not visible to us, right? We can't see them. Mobile phone, internet, etc., is all using radio waves, but you don't see radio waves floating around, and your eyes or your senses do not detect them. Whereas when it comes to the visible light, that is one part of the electromagnetic spectrum that our eyes are able to detect, and that's why we are able to see this colorful world, because of the visible light. But until now, when it comes to uh, infrared also obviously is invisible, but again we can feel it as heat if the intensity is sufficient, and any source of heat, even if you light a matchstick, the heat that you can feel from it, basically you can say that infrared are actually related to it. Now, this heat property of infrared is actually also useful. For example, we have the infrared cameras, or we have the night vision cameras, etc., which are used in places where visible light is absent. For example, in our national forests, in our wildlife sanctuaries, etc., there are camera traps that they put. So these camera traps basically try to detect the movement of animals at night, so that we would understand their behavior, their pattern, their preying habits, etc. So for that, what we do is that there are camera traps that we place in the wildlife sanctuary or the national park, and we try to track the movement. Now, because these are areas which are completely dark, right? At night it will be completely dark, there's no source of light whatsoever. So that's why you cannot use a normal camera. You can't use a normal camera. You'll have to rely on these kind of technologies like infrared. Now, why infrared will be working here? Because movement means what? Movement means that you're using energy, that even if you're walking, you need energy to walk, and that energy will dissipate at heat as heat, correct? That's what happens with you. For example, if you start running, you'll feel that heat, yeah, right, you'll feel that heat, and you'll start sweating. So when you do that, when that happens, energy is being released by the body, and this energy being released is where the infrared actually will be detected. So that's why in the same case, when it comes to even the movement of the animals at night, we'll be able to detect their movement with the help of this infrared. So that's how we see that infrared. So why have I written infrared red? I had to write infrared cameras. So this is where we see that infrared can be useful. Then we have the visible light, frequency between 400 to 800 terahertz, and wavelength between 740 nanometers to 380 nanometers. Now, in this case, when it comes to visible light, I mean, for us, there is no other part of the electromagnetic spectrum, perhaps, which is important, because we are able to see the world, perceive the world. Our eyes are able to see around, look around only and only because of this visible light. Now, is there any other application? Yes, there is. There is a kind of communication which is called as visible light communication. We'll discuss more about it. Visible light communication. Now, this visible light communication is where we make the use of visible light. We make the use of visible light to for some kind of wireless communication. We'll discuss that later, but it can be used. All right, and this is the last wave that can be used for any kind of communication. So if we want, we can use radio waves. In certain cases, we use microwaves. In very limited number of cases, we also use infrared, and in limited number of cases, we can use the visible light. Now, all the left over three waves cannot be used for communication now. Why can't we use it for communication? Give me the answer, please. And then I'll give you the answer if you are not correct. Why do you think we can't use ultraviolet or X rays or gamma rays for communication? They are harmful to us. Yes, many of you have written this, correct. High energy, of course, correct. Yeah. Huh. So most of you have given the correct answer. So basically now what's happening is that now the frequencies are high, the wavelengths are short, the frequencies are high, so energy is high, energy dissipation is high. So first and foremost, that blocks it out. Secondly, obviously very harmful for us, because they have high frequencies and they have high energy. So that's why ultraviolet, x-rays and gamma rays, these cannot be used for wireless communication, or we don't use it. I mean, theoretically can we use it? Theoretically yes, we can use it, but practically it's impractical for us to use them. All right. So ultraviolet, x-rays and gamma, these three we don't use for communication. We don't use them for wireless communication. All right. So in case of ultraviolet light, the frequency is between 8 into 10 to the power of 14 to 3 into 10 to the power of 16 hertz, and wavelength between 380 nanometers to up to 10 nanometers. All right. Now in this particular scenario, when it comes to ultraviolet light, there are three types of ultraviolet light. There are three types of ultraviolet light. You have UVA, UVB and UVC. So what is UVA, B and C and how they are different? Let's try to understand that. First one is UVC. Now UVC has a wavelength between 100 to 280 nanometers. All right, 100 to 280 nanometers. Now in case of UVC, we are talking about wavelengths that are the shortest. I mean, among the UV rays, this is the shortest. So because shortest wavelength means highest energy, means highest frequency, means highest harmful also. But at the same time, when it comes to UVC, you might know that sunlight, the sunlight that is incident, the solar radiations that are incident on the earth, they don't only carry the visible light, they also carry the ultraviolet light. Correct. They also carry the ultraviolet light with them. Now this ultraviolet light can be harmful for us. All the three types of ultraviolet light, UVA, UVB and UVC, all these three are a part of the ultraviolet light that comes with the sunlight. UVC being the most energetic, highest frequency, and that's why very, very harmful. Thankfully, what happens is that there is this ozone layer. The atmosphere has an ozone layer, right? This ozone layer helps us to shield from UVC. UVC is something that is completely absorbed by the ozone layer, and that's why it never reaches the earth. So the most harmful part of the ultraviolet light doesn't reach the earth. Otherwise, if there was no atmosphere, if there was no ozone layer, then life perhaps would not have succeeded on the earth as it has, if it was about ultraviolet C. But there are some man-made sources also, although very small sources as compared to, obviously the sunlight can't be compared, but very small sources. For example, welding torches. So you might have seen that whenever somebody is doing welding, they always wear a shield. Correct. They always wear a shield, and that shield helps them protect from the UVC. Similarly, there are germicidal lighting where we kill the germs with the help of UVC. So but those are very controlled amount of UVC that will not be harmful for us, because they are in very small quantities. At the same time, even in filtration processes it is used. For example, if you look at the advertisements of the water filters, or even if you go to a shop and just ask them about water filters, they'll tell you that they have RO plus UV plus UF plus XYZ kind of technology. So that when they say RO plus UV, this UV is ultraviolet. They use ultraviolet light basically to kill the microorganisms, kill the bacteria, etc. Because RO can filter, RO cannot kill, UV can kill. So that's why for filtering out the chemicals and the particles, etc., RO is good. But for killing the life forms, you need UV. So that's why RO plus UV. So that's why UV, we see that ultraviolet C will have its own usage in all these kind of cases. Then we have ultraviolet B, which has wavelength between 280 to 315 nanometers. Now, in this particular scenario, when it comes to UVB, obviously it has a higher wavelength, a longer wavelength. So that's why it is less harmful, but it is still harmful. All right, it is still harmful, but again, thankfully, what we see is that mostly they are also absorbed by the ozone layer. But just about, you can say, 5% of UVB is able to penetrate through the through the ozone layer and reaches the earth. Otherwise, almost 95% of the ultraviolet B is also absorbed by the ozone layer. Only about 5% is able to reach the surface of the earth. Now, they can lead to sunburn. They can cause skin issues. They can harm the top layer of the skin, and they can also lead to aging of the skin. So that's why we see that there are all these issues that we have with UVB, that is ultraviolet B. Now, coming to ultraviolet A, we see that ultraviolet A is generally between 315 to up to 380 nanometers. Now, obviously, it has the highest wavelength, sorry, longest wavelength, and that's why energy is the lowest, and that's why it is not going to be as harmful as UVB. But almost 95% of ultraviolet A is able to penetrate through the ozone layer and reach the surface of the earth. And that's why we see that it can lead to a lot of skin issues for us, because UVB, we discussed that it largely affects the top layer of the skin, but ultraviolet A can also go beneath it, and it can cause trouble for the skin. So that's why we see that aging of the skins and wrinkles, etc., all these things are possible with UVA. At the same time, we see that UVA, or very very long exposures to UVA, also has been linked with cancer, with especially with skin cancer. So that's why there are all these scenarios also. Again, it's not proven, and it's not, we don't know whether it's correct or not, or in what proportions it is wrong, or it can be harmful. But we still see that there are all these issues. So that's why when you look at any sunscreen, the if you look at the sunscreen pouches, or their cases, you'll see that they'll talk about protection against UVA and UVB. They'll say that, if they when they advertise, they'll say that they protect you from UVA and also UVB. Right, they'll say that they'll protect you from UVA and UVB. So that is why they say UVA and UVB, because UVA largely because of its volume is harmful, and UVB because of its strength is harmful. So uh, that's why we see that all these things will be mentioned, and you will see that they'll say SPF, so sun protection factor is SPF. So SPF 40, 50, 60, etc. will be required if you have longer exposures and higher exposures to sunlight. So that is how we see that there are all these different types of ultraviolet light. Then we have X-rays. Now, in case of X-rays, there are two types of X-rays. We have soft X-rays and hard X-rays. So soft X-rays basically comprise the range of electromagnetic spectrum between the UV and the gamma rays. So they have a range between 3 into 10 to the power of 16 to 10 to the power of 18 hertz, whereas wavelength is in the range of 10 to 100 nanometers. All right, 10 nanometers to 100, sorry, 10 nanometers to 100 picometers. 10 nanometers to 100 picometers. Now these are X-rays, so they can also be used for imaging. For example, you might have seen that if any bone fracture, etc., happens, then the person would be advised to go through the X-ray. So that X-ray basically will take the image of the bone, because it is able to penetrate through, it has higher energy, so that's why it is able to do that. And because of that, higher exposures to it obviously can be harmful, and that's why there are shields, etc., all around. Even in the medical facilities or hospitals, wherever they have the X-ray facilities, you'll see that they either are corners of the rooms or well shielded rooms, and metallic plates will be there all around. So they take all these precautions so that they do not expose anyone to higher quantities of X-rays. Otherwise it can be very very dangerous, and it can lead to eventually uh, cancers, and even it can lead to death of the person. So that's why it can be very dangerous from that perspective. So that's what we see with X-rays. Then after that, we so that's basically the soft x-rays. Then we have gamma rays and the hard x-rays and gamma rays. They basically have the same electromagnetic spectrum. So frequencies are greater than 10 to the power of 18 hertz, and wavelengths are less than 100 picometers. Wavelengths are less than 100 picometers. Now gamma rays can be very very dangerous. They have the highest energy. They can be very damaging, very dangerous. They can lead to somebody's death. They can just burn through skins and tissues. So that's why they are very very dangerous. But they can also become useful in very controlled manner. So for example, we discussed, if you remember, in nuclear technology, we had discussed about pest control in agricultural applications. So that pest control or food quality control, etc., is done with the help of gamma rays, because gamma rays have very high energy. So controlled amount of gamma rays are used so that we can kill the microorganisms. Similarly, even in many of the radiation therapies, like even in let's say the treatment for cancer or in chemotherapy, we see that gamma rays in a controlled manner can be useful there, where controlled amount of gamma rays will be passed through the cancerous cells so that we can kill those cancerous cells. So there are all these things where we see that we find the use for, even in the case of gamma rays. So that is basically what we see with regards to it. So uncontrolled exposure of of course will be extremely dangerous for our being. So any question from here? Anything? Frequency, that's why higher energy, hence more harmful. How will India destroy any powerful missile after launch? Basically, we can detect them. That's why these systems, these very complex systems, have been designed in a manner that they can actually uh, compute the trajectory of any incoming missile or aircraft, and they can launch a counter attack against them. At what time UV rays are prevalent? As old people say, morning sun rays are good for health. Yes, morning sun rays are of course good for health. And see, we are talking about prolonged exposure to sunlight. So it's not about the fact that whether you are just exposing yourself to sunlight for half an hour or so. That's okay. That's, I mean, that's good for anyone because you need those vitamins also, and vitamin D can be synthesized in the body in the presence of sunlight. But when the exposure is very huge, I mean when the exposure is very high and all throughout the day, etc., for a prolonged period of time every day, then in that case it can be more dangerous, and otherwise not. By our mobile towers, which can be easily controlled and fix the frequency for traveling much faster. As the mobile service tower radio frequency has been increased by the telecom service provider, it will affect the living species, especially birds, and it can cause migration of birds and will affect their reproductive capacity. So there are reports that have been actually published on it, that it may have a negative impact. But the problem is that there are many reports and there are many contrasting views from these reports that have come. Many of the reports have said that it can harm, many of the other reports have said that it will not harm. So that is where we see that there has been a lot of discussion about how exactly radio waves have an effect, or if at all they have an effect on birds, and still remains a topic which is much debated. Why does Bluetooth have very short range? We have not discussed Bluetooth. Just wait. Hard X-ray frequency and wavelength exactly same as gamma rays. Exactly same as gamma rays. Confused between frequency and wavelength. Look, wavelength is the length of the wave, the distance between the 2 points. Whereas in case of frequency, you are counting how many waves between these 2 points. You're counting how many waves are passing through given area in 1 second. So when you are just counting that number, then it is about frequency. And when you are just looking at the distance between two similar points, it is wavelength. Prithvi, Agni, Trishul, Nag, Akash are cruise missiles? No, they are ballistic missiles. Does our body emit infrared during work? Yes, it does. Whenever it dissipates energy, it does do that. Are we using gamma rays in today's time? Absolutely, we are, and in a lot of ways we are using it. In As I told you that in medical therapies also we use it, in agriculture we use it, everywhere we are using it. What's the reason for calling soft and hard? It's largely based on their wavelength and their properties changing to being much harsher when the wavelengths are much shorter. Once explain the radar. A radar, what I said is that radar is a system where signals, or rather wavelengths, will be emitted by a transmitter. All right, these will be radio waves and microwaves. They will be emitted, they will go, and they will collide and come back. All right, they'll hit a surface and they'll come back, reflect back from there. So what we do is we calculate the total time that it took for it to go and to come back. So we calculate the time, we know the time that it took for the transmitter to transmit and the receiver to receive. We know the time, we know the speed of this electromagnetic wave, hence we can calculate the distance, or you can say the trajectory of any incoming aircraft or missile. X-rays that are used in medical are the same as you explained? Yes, of course they are. Light absorbing vitamin, name it's vitamin D. Vitamin D, you might have heard that if you remain in sunlight for some time every day, you will have a higher amount of vitamin D, because then only synthesis can actually happen. Lasers are different. Lasers are not related to this. Does RO UV water harm? No, it doesn't. It actually filters the things for you, so makes the water cleaner. And that's it. And if you don't have to ask questions from what has not been taught it, let the chapter complete, and then you'll all have your answer. Important for your examination yet, unless something big happens there. But just like, as I told you, just like throwing a ball, so that kind of path will be called as the parabolic path, and that's the path that ballistic missile takes. And cruise missiles will have a path which are comparable to an airplane. How you are able to control the path of an airplane, similarly you will be able to control the path of a cruise missile. So that's the basic difference between the two. I think the link was posted here itself. Tomorrow is the last class. Yes, tomorrow is the last class, and Wednesday we'll have the doubt session. So this chapter will probably complete in the first 1 hour of tomorrow, and then after that, the second half of tomorrow's class will be about intellectual property rights. So these are the things that we are going to do in tomorrow's class, and we'll be able to finish the session tomorrow. And Wednesday session will be the doubt session. We see sunrise and sunset reddish color. Why? That's because of the dispersion of light property that happens. Hmm. So let's take a break here. We'll but all the different types of wireless communication, the important types of wireless communication, in which when it comes to Bluetooth, it has been one of the most important forms of wireless communication and a very popular one as well. I'm very sure that everyone who's using a mobile phone or a smartphone, you're aware of Bluetooth and you might have used Bluetooth sometime. Now, when it comes to Bluetooth, uh, this is basically short range communication, something that your mobile phone enables. So for example, if either mobile phone, or we have a lot of electronic gadgets today which are also connectable through Bluetooth. For example, speakers or headphones, etc., they can also connect through Bluetooth, and there are a lot of different types of electronic devices that could connect via Bluetooth. So there are a lot of ways in which Bluetooth is being used. Now Bluetooth is used for short range communication. It's used for short range communication. Now, just understand something. In case of communication, when we talk about radio waves, we said that radio waves can travel long, right? Radio waves can travel long, and that's why for wireless communication they are important. Now, that is a perspective of when you need satellites. So, for example, when you need satellites for mobile phone communication, so mobile phone communication can happen between the Earth station. So, what happens is that the information relay will happen between the Earth station, the antennas on the Earth, to the satellites, and then back from there. And all that can happen very quickly because of the speed of the electromagnetic radiations or speed of the radio waves. So that's why it's not that radio waves cannot be used for shorter range communication. They can be used for shorter range communication as well. Just that they will be more useful. I mean, they will perhaps be the only ones useful when the range is long. In the short range, others could have been potentially useful, but yet, because they have long wavelength, the dissipation of energy, the loss of energy will be very less with radio waves. So they can be used for short range communication and long range communication. Now, in case of long range communication, what you simply need is, if range is long, frequency will be low. If the range is short, the frequency will be high. And precisely this is what we see with Bluetooth, that it uses ultra high frequency radio waves. So radio waves being used here are of very high frequency. So that's why ultra high frequency, or UHF. Now in this particular scenario, when it comes to Bluetooth, we see that Bluetooth has short range, and it operates on something called as frequency hopping spread spectrum. Frequency hopping spread spectrum. Now, spread spectrum communication is something that is very, very useful whenever you want secured communication. All right, because of this, it will have, it would be able to establish secured communication. Anyone here in the classroom who is an electronic engineer, electronics and communication engineer? Now, nobody will say yes, because spread spectrum communication, you might have studied it as a part of electronics and communication engineering, if at all. So there, spread spectrum sometimes as additional subject, option subject, is also taught to people, but especially this is a kind of digital communication which is used especially when it comes to uh, secured communication. Even in military communication, for example, spread spectrum communication is used. So we see that something similar is used in Bluetooth as well. And with that, what we see is that Bluetooth is able to uh, uh, establish communication which is actually very secured. Then the operational frequency, just remember this as a fact, that the operational frequency is 2.4 gigahertz. All right, it is 2.4 gigahertz. So it operates on a frequency that is 2.4 gigahertz. That's it. So just remember this much, nothing else. And range is generally 10 meters, less than 10 meters. So only in 10-meter range it will be connectable. Otherwise, it cannot connect beyond that. So, and if let's say you have wide open spaces, then perhaps little beyond 10 meters, but more or less we can say that 10-meter is the range. And even though, let's say, even if there are walls and doors in the way, even then it will be useful. Even then Bluetooth can be used. For example, you can connect your devices within two different rooms with Bluetooth if the range is less than 10 meters. All right. So both sides of a wall you can connect it through. So in this manner, we see that this is how Bluetooth communication works. Now, apart from this, there is near field communication as well. Now, in case of near field communication, we are talking about peer-to-peer communication, meaning where you have two devices that have to be placed very close to one another so that they can communicate. So that's why if you see here, the range is less than 10 centimeters. Bluetooth 10 meters, here 10 centimeters. So 100 times lesser than Bluetooth. So it's a very, very short range communication. So the devices have to be literally touching each other, then only this communication can be established. Normally, what we see is that the range is only 3 to 4 centimeters. The most that the range could be is up to 10 centimeters. So it's a very short range communication. The the devices here can act as both reader and a tag. What does it mean? So when it comes to this kind of a communication, near field communication, you'll see that again your mobile phone devices might have NFC enabled. So you'll see that near field communication can work, that if you have two devices that are close, very placed very close to one another, you can do data transfer between them. So that can be enabled. At the same time, a lot of payments etc that are done, they can also be done with the help of NFC. So for example, you might have seen that today there are debit and credit cards which will just be tapped on the machine, and by tapping on the machine you'll be able to give the payment from there, right? So that basically is also NFC. Similarly, how what we see is that, let's say if you have used metro cards, or let's say even in offices, the uh, identity cards etc that are used, you just swipe it against the door or swipe it against the machine, and you see that the things are done, the information is exchanged. So in all these kind of cases, we see that near field communication works. In all these cases, near field communication works. So especially when it comes to near field communication, it's a communication to be established at a very close range. All right, at a very close range. And even in making payments, it can be used. So there are changes that you can make. For example, you can, if you want, you can encrypt that communication as well. So we can encrypt the communication so that communication established is also secure. So there are all these kind of cases that where we see that near field communication is useful. Read this question. This was asked in your paper. NFC side of the radio wave, the one, it is a contactless communication technology that uses electromagnetic radio field. So contactless communication, that is true. It is what? It is wireless communication, right? So that's where contactless communication uses electromagnetic radio fields. So this is also correct. Radio waves are being used. So statement number one is correct. Statement number two, NFC is designed for use by devices which can be at a distance of even a meter. Is it possible even a meter? What did I tell you? The devices have to be very close. How much is 1 meter? So this is a wrong answer. This is a wrong statement. We discussed that it cannot be more than 10 centimeters. It cannot be more than 10 centimeters. So even a meter, there's no even not a choice at all. So, and that to 10 centimeters even is a huge distance. Largely, they'll just be almost touching each other. Then only they are able to establish the communication. So largely, it is not even more than 3 to 4 centimeters. Forget about a meter. 1 meter is how much? 100 centimeters. So it's lesser than that. NFC can use encryption when sending sensitive information. This is correct. We discussed that the payments etc when we are making, then in that case we can make the use of NFC. So that's why 1 and 3 only. After this we have radio frequency identification or RFID. Now, in case of RFID, what we see is that this is also a communication which is very similar to how NFC works, but with a difference as compared to NFC. So, for example, in NFC, we know that the range is only up to like 10 centimeters, whereas in this case, the range can be up to 100 meters. So, that's why it's a big range that we are talking about as compared to NFC. Now, in case of radio frequency identification, RFID can be a much faster mode of communication also as kind of compared to NFC. It can work much faster, and why it can work much faster is because of the fact that there are certain changes in the technology or certain advancements in the technology as compared to NFC. So for example, in case of RFID, what we see is that there are hundreds of tags that it can read in 1 second. So in case of NFC, you will be able to read just one tag at a time. So it will take time for you to establish that communication or to finish your work. But in case of RFID, it can happen much quicker. So in case of RFID, there is one very famous example today in India where RFID is being used, and this is FASTag. In FASTag that we have at the poll booth, the toll plazas, etc., that is where you'll see that FASTag is being used. That the car or the vehicle will go near the toll plaza, and you'll see that the toll payment will be taken automatically with the help of RFID. So that FASTag basically is RFID based FASTag, where you have a reader placed in front, and it will be able to detect the RFID that's that pasted on the vehicle, and it will be able to take the payment, and a seamless flow of traffic can be established at these kind of junctures. So this is how fast tag basically could work in these scenarios. And similarly, we see that there are other areas where we can make the use of radio frequency identification. For example, RFID can be used in libraries. They can be used in libraries, they can be used in warehouses. They can be used in libraries, and they can be used in warehouses. So even in a library, for example, there would be thousands of books perhaps. So reading through all the thousands of books can be done through RFID. If let's say NFC was being used instead of RFID in these cases, then you would have to go to each and every book and take the information from there. Whereas in case of RFID, you can simply just stand at one place and scan the entire area. So that's why it makes it much easier and simpler for anyone to work with RFID. Then what we see here is that no line of sight is required. So line of sight means that if there is any obstacle, then that communication would not work. That would be no line of sight. But in case of line of sight, what we see is that when we say that no line of sight is required, it means that even if there are obstacles in the way, still it'll be able to manage. It will be able to pass through those obstacles. So it will be able to pass through the walls, for example. So it means that it can pass through obstacles. All right. So in this manner, we see that this is how RFID would work. Now coming to a very important topic, and this is Wi-Fi. Now when it comes to Wi-Fi as a technology, Wi-Fi stands for wireless fidelity, and operating frequency can be either 2.4 gigahertz or 5 or 5.2 gigahertz. Now in this particular scenario of Wi-Fi, we all know that perhaps a lot of you watching this lecture also, perhaps you are using some kind of Wi-Fi technology. So Wi-Fi technology in the last decade has become a very crucial and a very popular technology, that from being something which was just being used in some offices here and there, today it has just become a household name. And probably at least in the metros, everywhere we see that Wi-Fi's are very easily available. And forget about the metros, even in tier 2 and tier 3 cities in India, very easily Wi-Fi connections are available. So we have seen that Wi-Fi has grown as a technology, has become very popular as a technology for the kind of ease of use that it has, the kind of uh, easiness in your daily work process that it can provide you. So that's why we see that because of that ease of work, that the ease of use, Wi-Fi became very popular. So we started with Wi-Fi 802.11a. This was the first time something, a wireless connection of internet could be arranged. Until now, internet connections would always be dependent on some kind of telephone line, some kind of broadband network, but it will not be able to use a Wi-Fi signal, and you cannot just roam wirelessly. If you want to connect to internet, you'll need some kind of wire that connects to it, and then only, otherwise mobile phone cellular networks came later. Then after that, 802.11b came in, where we saw that now multiple devices it would connect to, and slowly and steadily it started to gain some kind of market. Now, by the time it came to this 802.11n, this is where until now Wi-Fi had become a very famous technology, very popular technology, and owing to this popularity, this was named as Wi-Fi 4. Just to make the nomenclature easier, this was named as Wi-Fi 4, and subsequently these were named as Wi-Fi 3, 2, and 1. And then after that, the next technology that came in, this was Wi-Fi 5. This was Wi-Fi 5. Right now, most of us are living in the era of Wi-Fi 5. All right, this is largely being used in today's world. Now in this particular scenario, when it comes to Wi-Fi 5, we see that today almost everywhere Wi-Fi 5 is available, although Wi-Fi 4 and Wi-Fi 3 is also available. I mean, if you have Wi-Fi device at your home, just try to configure them if you want. I mean, whatever is the website or the network URL, you go there, you find the connections that are available for you. You'll find that all these things, Wi-Fi 802.11 N, G, AX, etc., not AX, rather AC, will be actually written there, and you will know all these Wi-Fi connections you are actually connected with. So in this manner, we see that Wi-Fi started becoming very popular. Now, the next Wi-Fi generation that we are looking at right now is Wi-Fi 6. Slowly and steadily, it has started coming up. We see that many countries, they have started using it wholeheartedly, and slowly in other countries like India, it is now starting to penetrate. So Wi-Fi 6. Now with Wi-Fi 6, we see that there are a lot of advantages. With Wi-Fi 6, there are a lot of advantages as compared to until now whatever Wi-Fi we have been using. So with Wi-Fi 6, there are two major technological changes that have come in. One is OFDMA and the second one is MUMIMO. Now OFDMA stands for orthogonal frequency division multiple access. We'll discuss about that. And this MUMIMO stands for multiple user, multiple input, multiple output. Now, what these technologies are, we'll try to understand, and what kind of difference does it make in Wi-Fi 6. Now, when it comes to Wi-Fi 6, first one is OFDMA, that is orthogonal. It will not be very crucial, but you should just know as a technology what exactly it is. Orthogonal frequency division multiple access. So that is what OFDMA stands for, orthogonal frequency division multiple access. And the second one is MUMIMO, that is multi-user. This is multi-user multiple input, multiple output. So that is basically what MUMIMO stands for. Now, these two basically are bringing in a lot of change in case of Wi-Fi technology. Now, what kind of changes, what kind of advantages? Wi-Fi 6 becomes much faster as compared to the current generation of Wi-Fi that we are using. It has lesser latency, it has better security, improved battery life, and higher number of device connections. Higher number of device connections. Now, what exactly am I talking about? Higher number of device connections. Now, in this particular scenario, when we look at Wi-Fi 6 advantages, first of all, it is faster. That the speeds that you're getting on your device will be faster. Lesser latency. Now, when it comes to latency, latency means lag. Latency means any kind of lag in the network. Now, this could be because of various different reasons. Lag in the network. So, lag in the network is meaning that after the relay of information, how much time does it take for you to receive that information? So, that kind of a lag in the network, that kind of a delay, all right, delay in the network or lag in the network will be called as latency. Now, this can happen because of multiple different reasons, all right, multiple different reasons. So, for example, let's say your computer is not working well, your computer is old, so computer does not respond well, so that's why it does not catch the signals as fast as it should. So that could be a reason. The internet connectivity may not be that good, that could be a reason. There are multiple devices connected at the same time, that could be a reason. Your device itself is not of a very high configuration, that could be the reason. So there are multiple reasons for which something like this could happen. For example, in the offices, there could be a central hub, a central server through which a lot of office devices are connected. Now, what may happen is that all these device connections, sorry, all these device connections that you have, because there are multiple devices connected at the same time, the network may become congested, and because of that there might be a lag in the network or a latency in the network. Similarly, you will see that in many cases. For example, sometimes if you are watching a video, you might see that the voice is coming first and the video later, or maybe the video is coming first and the voice is coming later. So these kind of scenarios happen because of latency, because ultimately the voice and the video, the audio and the video, they travel as two different waves. So if one wave is traveling faster than the other, then in that case you will receive that signal first. So if, let's say, the audio signal is traveling faster, then you will receive the audio first and then you will receive the video. So something like this can happen. I mean, if you, for example, many times in the news, if you see, if there is a ground reporting happening, a live reporting happening, the person who is on the ground will say something, and the person sitting in the studio will have to wait for like a couple of seconds before the person is able to hear it. Right, you might have observed something like this. So in all these kind of scenarios, we see that this is nothing but the latency. So latency might come in various different ways. Here in case of Wi-Fi 6, the advantage is that the latency will be much lesser. The latency will be much lesser as compared to whatever we see today. Even in this case, what is this picture? So those of you who have played this, yeah, this is former PUBG or the battleground, the new battleground. So now, yeah, the people who are saying BGMI are the people who played. So, so Battleground Mobile India, and formerly known as PUBG, a game that became very famous. Now, if you have played it, then you might have seen that there is a number that they publish or number that they display here. So this could be a 2-digit number or a 3-digit number. So this number basically that they show here, this is the latency number. This is nothing but the latency. So for example, let's say if when it comes to latency, if the latency number is 10 or 20 or 30, then it means that it has a latency of 10 milliseconds. That is the delay of 10 milliseconds or 20 or 30 milliseconds. So meaning that everyone else is 30 seconds faster. I mean, the network is 30 seconds faster than your device. But if this number is high, if this number is 300, 400, 500, then in that case, it means that you are 500 milliseconds behind the network, then the network latency is much higher, and that gives you an excuse to play badly. Then you can say everyone that look, my latency was high, or my what we call is at as a ping rate. Very commonly used term here is ping or ping rate. So you would say others that look, my ping rate was high and that's why I'm playing badly. So that basically is nothing but the latency number. So latency, if the latency is high, it also means that your experience with this kind of communication will not be good. So that's what happens in case of here, and that's why we see that most importantly these are the two advantages that you get out of Wi-Fi 6, that it is faster and it gives lesser latency. Now, one more thing very, very important is that a higher number of devices could be connected. Now, when it comes to Wi-Fi 5, we see that 6 to 8 devices can be connected as of today. And if you increase the number of devices beyond 4, 5, 6, then you might see that there is a decrease in the speed. Now, today, the number of devices every household has, which can connect to wireless networks like this, has been increasing. I mean, let's say if you are living in a family of 4 people, then at least there are 4 mobile phones, if not 6 or 8, if not 2 mobile phones per head. So, at least 4 mobile phones, at least maybe a couple of laptops or computers. Then, after that, there are other things that now also uh, connect to Wi-Fi. Maybe your television connects to Wi-Fi. Maybe your speaker systems connect to Wi-Fi. Maybe your fridge and even geysers and washing machines, etc. They also connect to Wi-Fi now. So there are so many things that can connect to Wi-Fi. So every household has number of devices now which could connect to Wi-Fi. So Wi-Fi 5, the present technology can take care of up to 6 to 8 devices, and after that the speeds will start coming down. Whereas when it comes to Wi-Fi 6, it would be able to connect to more than 30 devices. It could connect to more than 30 devices simultaneously, which is huge. And that is why this will be very, very crucial in this technology, and not only for your household use, but rather at a larger scale, even for things like Internet of Things. We'll discuss about Internet of Things later. So even for things like Internet of Things, we'll see that it will give you a much better response. So that's why it becomes very, very crucial from all these perspectives. And there are two key technologies that help in this. One is OFDMA and the second one is MUMIMO. So OFDMA is able to increase the efficiency, and thus it reduces the latency. Whereas MU-MIMO is something that will increase the capacity, and that's why it will result in higher speed per user. So in this manner, we see that these two technologies, they become very, very crucial from the perspective of Wi-Fi 6. Now, Wi-Fi 6 is not yet available at a larger scale in India, but we are expecting that very soon it will be available, because in other countries already Wi-Fi 6 connectivities are uh, available. So it's just a matter of time before it being uh, introduced by the private networks. So we'll see that this will come. So just remember these two names and what effect they have on Wi-Fi, and how exactly they change the Wi-Fi. Read this question. All right, so I'm launching the poll for you. there's a mix that 34% of you are marked A, 7% B, 29% C, and 31% D. So let me just discuss this with you once. What is the difference between Bluetooth and Wi-Fi devices? First, Bluetooth uses 2.4 gigahertz radio frequency band, whereas Wi-Fi can use 2.4 or 5 gigahertz frequency band. So we had discussed this. If you see this, operating frequency for Wi-Fi is 2.4 and 5.2 gigahertz, whereas in case of Bluetooth, it is 2.4 gigahertz. So so this is what it says. So 5 basically is 5.2, you can say that. So A is correct. Bluetooth is used for wireless local area networks only, whereas Wi-Fi is used for wireless wide area networks only. Now, when it comes to networks, there are different types of networks. We have personal area network, then we come to local area network, then after that we have wide area network, and then we also have something called as metropolitan area network. All right, so all this is on the basis of the kinds of network that you have or the range of the network. So personal area network is basically something which is within a room. So then you'll say that it is personal area network. Local area network could be a building or a couple of buildings, one building or maybe a couple of buildings, or maybe just a floor. Just a floor. So that is what local area network would have connection to. Wide area network could be more about a locality or some kind of area. So an area inside a city. So that will be wide area network, and metropolitan area network will be, it can cover the entire city. It could cover the entire city. So this is how range wise these are arranged. Now look at B. Bluetooth is used for wireless local area network only. Now, Bluetooth is very small range. We discussed that either within a room or just a small area, up to how much? Up to 10 meters of area can be covered. So, wireless local area network only is wrong, because in personal area network also you'll be using it. Wi-Fi is used for wireless wide area networks only. So Wi-Fi will be useful where? In personal area network also it can be used. In local area network also it can be used. So largely it will be used for these two. So that's why this is wrong. C says when information is transmitted between two devices using Bluetooth technology, the devices have to be in the line of sight of each other. Now this I did not expect that you will mark as correct. Simple reason. You are using Wi-Fi. I'm sure that many of you, if not all of you, have used Bluetooth. Now, does Bluetooth get restricted when you are between two rooms? It can connect between two rooms. We discussed this also, that it will have range up to 10 meters, and with between two rooms also you can connect it. So it's not that you can't. If these are very far apart, all that matters is the range, 10 meters range. So if I have a wall or a door, this side and this side can connect if they are in the range of 10 meters. So they don't have to be in the line of sight. Line of sight meaning that there should not be any obstacle, right? This is what we had discussed about line of sight, that there should not be any obstacle. So that's why this is wrong, that they do not have to be in the line of sight. There's no reason for that. When Wi-Fi is used, the devices need not be in the line of sight, so that is fine. This is okay. But the first part is wrong. The first part is wrong. So anyway, D says both A and B, so it's wrong. So correct answer is A. I understand your confusion with B because you might not have an information about B, but C was an easy thing. That's something that you see in your practical life every day. It's not even something that we are teaching, or you are just seeing this in the classroom. Then we come to Li-Fi. Now, Li-Fi stands for light fidelity. Now, when we say light fidelity, the meaning of the term light fidelity is that here we are making the use of light. We are making the use of light for some kind of wireless communication. So this is, we say that a type of this is a type of visible light communication. Visible light communication, meaning that we are using visible light for establishing wireless communication with with Wi-Fi. Now that's what, so it transmits data via light almost up to 100 times faster than Wi-Fi. All right, 100 times faster than Wi-Fi, speed up to 224 gigabits per second. So speeds can go up to 224 gbps. It runs on the light waves, so this is the range of light waves. Signals, while Wi-Fi signals cannot be passing through walls, so that's why this will be called as line of sight communication. This is line of sight. This is line of sight communication. Now why? Because light is being used. Can light pass through walls? Light can't pass through walls. So that's why any communication also that you're establishing through light will not be able to pass through walls. Correct? If light was able to pass through walls, you'll need just one light bulb in your home and it will light up the entire house. Unfortunately, that doesn't happen. For every room, you need something separately. So, because light cannot pass through walls, so that's why even when you are establishing Wi-Fi, it also cannot pass through walls. So that's why we say that it is line of sight communication. And security wise, we say that it has better security as compared to Wi-Fi. Now, the question is, where do we use Wi-Fi? Where do we find the use of Wi-Fi? So, generally speaking, when you can't use radio communication, when you can't use radio waves for establishing your communication, that is where you look for these kind of communication. For example, inside inside an airplane. Now, inside an airplane, what happens? That you would be asked to put your phones on flight mode, correct? Mobile phones will be put on flight mode or airplane mode. Now, when you put your phones on flight mode, what happens is that your phones cannot transmit or receive radio waves. Cannot transmit or receive radio waves. This is what happens with flight mode. That when you are in flight mode, you can't transmit or receive radio waves. All right, you cannot transmit or receive radio waves. So that's why inside the aeroplane you'll see that you would be asked to do that. Why? Because the pilots will be using radio waves for their communication and they don't want any kind of interference. There are chances that the radio waves from your electronic devices might interfere with the communication that pilot is establishing. So that can be very, very dangerous. It can be very, very harmful. So that's why every passenger is asked that please put your phones on flight mode or airplane mode so that your phone does not interact with the radio waves, and hence the flight communication or the pilot's communication would be safer. Now, in such a scenario, we see that Li-Fi becomes useful because then inside this airplane, you can use Li-Fi for any kind of establishing any kind of communication. Even the internet can be provided with the help of Li-Fi. Now, Li-Fi is using light, so that's why there will be no interference because the frequency or the wavelength of radio waves are completely separate and of light waves are completely separate. So that's why between these two there will be no interference. It's like two different roads. There are two different roads, so there will be no interference between the two. All right, so that is basically where we see that Li-Fi will be useful, but there are a lot of different ways. For example, in defense communication also, many a times when there is a jammer or there is, let's say, no chance of establishing radio communication, then we look for infrared, microwaves or light rays, etc., to establish some kind of communication. So all these scenarios we see that Li-Fi actually can be used with the help of these kind of uh, in these kind of scenarios. Read this question, very simple question. I'm launching the poll. Yeah, so lot of you have given the correct answer. Great. So 84% of you have given the correct answer. It should have gone little above this number. With reference to Li-Fi recently in the news, which of the following statements is or are correct? First, it uses light as the medium for high-speed data transmission. Both are correct. Remember that there are two parts to this sentence. One is light as a medium, and second, high-speed data transmission. And both are correct. So that's why statement number one is correct. Statement two, it is a wireless technology and is several times faster than Wi-Fi. Wireless technology, yes, it is. Several times faster than Wi-Fi, yes, it is. Almost 100 times faster. So that's why both these statements are correct. Another question that has been asked from this topic only, you can say. I'll just give you one hint that when they say 375 to 780, this is more or less light range only. Range can differ a bit. You will, if you go to 10 different sources, everyone will show some difference in their uh, in their numbers. So some might say 400, some might say 370, some might say 380, and so on. So these kind of differences come in. So don't worry about those differences. Please mark your answers. Hmm. So largely you are confused between A and C, and I know why that has happened. The correct answer will be C. Let me tell you about this question. With reference to visible light communication technology, which of the following statements are correct? First, VLC uses electromagnetic spectrum wavelengths between 375 to 780. Anyway, I told you that this is correct. This is the light range. Second is VLC is known as long range optical wireless communication. Long range. Can it be long range? What we discussed, within a room. Correct? Within a room. So two definitely is wrong. Two definitely is wrong. So I don't. So that's why you should have gotten the answer from here. That 2 for sure is wrong, because this is not by any stretch of imagination this is a long range communication. What we discussed is that only within a room you can uh, do this communication. Remember that this is what, it cannot pass through walls. It is a line of sight communication. So if it is a line of sight communication, how is it even possible that a long range communication can be established? It's not possible at all. It's a very, very short range communication, only within a room. We establish it just within a room, right? So that's why second is wrong. VLC can transmit large amounts of data faster than Bluetooth. This is correct. We discussed that it is faster than Wi-Fi. Wi-Fi anyway is faster than Bluetooth. So obviously this is faster than Bluetooth. Fourth statement is VLC has no electromagnetic interference. Now this is a little dicey statement. This is a little dicey statement. Is the reason for that is this word, no electromagnetic interference. Now when it comes to VLC, What we discussed is that we use it when we don't want any interference. So wherever we don't want any interference, this is where Li-Fi becomes useful for us. But saying that it has no electromagnetic interference would be wrong. What if there are two different Li-Fi sources in the same room? Then in that case, there are chances that this kind of a scenario may arise. It's a very exceptional scenario, but it's a possible scenario. I think that it's more of a language problem that they might have had while giving this particular question. By asking these questions, there might have been some kind of problem while designing these questions, because what ideally they should have written is that VLC is used when we want to have, or rather when we want to avoid electromagnetic interference. So this would have been an ideal way to put this. But saying that it has no electromagnetic interference in the strictest of the senses, I would say that this is a wrong statement, because if there are two similar sources of Li-Fi in the same place and both are propagating messages, then in that case there are slight chances that in between them there could be an interference. So that's why from that perspective it would be wrong. But the way they have asked this question, I think, is more it's about the interpretation. And when they say no electromagnetic interference, they wanted to basically ask something that we discussed, that when you don't want any interference, this is where you use Li-Fi. So the correct answer from that perspective can be 1, 3 and 4. Otherwise, strictly speaking, I would say 1 and 3 only. Strictly speaking, I would say 1 and 3 only. And if not, if it's about the choice, second statement is definitely wrong. All right, second statement is definitely wrong. So that's why from that perspective, C is the most appropriate choice. And that is what your instruction book on your question paper also says, that pick the correct answer or the most appropriate answer. So in this scenario, even if it is not the entirely correct answer, this is the most appropriate answer. But I would still say that it was a mistake from their end, that they asked this in this kind of a language. They shouldn't have. And this question also came in the same year when the nanotechnology question had come. So that's why I was saying that 2020 paper overall, some for some reason was like this. I don't know what they were thinking while making these question papers, but they actually asked these kind of questions. Now, coming to the next topic, and this is about the evolution of mobile networks. Now, when it comes to the mobile networks, today we know that we are in the era of 5G. Now, what is the meaning of 5G? 5G means fifth generation, right? 5G means fifth generation. Now, when we say fifth generation, it obviously means that there have been four generations before this. So that is basically what we have in this part of our discussion. Now, when it comes to the evolution of the mobile networks, it started with the first generation where it supported only voice, meaning that you would only be able to talk on the phone. You can only talk on the phone. So that is basically what it means by supporting voice only. So that was the first generation of mobile phone which was introduced to the world in 1980s. The speed was also very limited. 2.4 to 14.4 kbps is the speed at which the transmission of information could happen. Then comes second generation of mobile phones, where now the speeds go up to 50 kbps, and it could support both voice and data. It could support both voice and data, meaning now you could talk on the phone and also use the internet, right? Basically, it means voice and the internet. So this basically changed the mobile phone, because now we could use internet on the mobile phone. Although it was not the kind of internet that you use today. I'm not sure if you have used internet in 2007, 2008 and thereabouts. You would know the pain of using internet on your mobile phone. That the amount of time it would take just for a very simple search. That even if you are doing a simple Google search, then type in whatever you want, just go, have your lunch, come back, you'll get the entire search. So it was not that easy. It was very very slow, but it was new. It was a privilege to have, even if it was very slow. But at that was 2G internet, where the mobile phone network speeds or internet network speeds would go up to 50 kbps. Then after that, 3G came in, and in case of 3G, we see that the speeds could go up to 3.1 Mbps. And again, of course, it also supports voice and data. So 3.1 Mbps was a big jump, and now at least you could watch videos, that you could go to YouTube and even think of watching a lecture or a video on YouTube. So all these things could happen uh, with 3G. So 3G was a new introduction. I mean, these dates that you see, these were the dates when it was introduced to the world. In India, it came much later. India kept on catching up. Now we have, you can say, almost caught up. That we are almost in time with the release of other mobile phone networks or other generations of mobile phone networks. But that was not the case back then. So 3G in India came almost 20 years after its introduction to the world. So then with 3G, at least a faster internet was possible. Then came 4G network, where we see that the speeds now started going even further. Up to 100 mbps is the speed that we are witnessing. This is all up to. This is not the ideal speed, unfortunately, because even if it says that the speeds can go up to 100 mbps, I I would hardly have seen anywhere in India where the speeds are as high as 100 mbps. But still, when it comes to fourth generation, it was a big jump, that now you could live stream, that lectures like these could be live streamed on your 4G network, which was not possible until 3G network. So here also it supports both voice and data. Now here comes one more very very important update with 4G, and this was the use of LTE and VoLTE. LTE and VoLTE. LTE stands for long term evolution. LTE is long term evolution. All right. And VoLTE is voice over. This is voice over long term evolution, that is voice over LTE. So this is what VoLTE is. So LTE and VoLTE, these existed in the 4G era. Now, when it comes to LTE, until LTE, you can say in 2G also, in 3G also, and up to 4G LTE, what we saw was that you could either use your phone, I mean, either you could talk on the phone or you could use the internet. You can't do both at the same time. If you are talking on the phone, you would see that the internet connectivity goes, right? Internet wouldn't be connected if you are talking on the phone. And when you disconnect the phone, this is where the internet would reconnect. So that is what was happening until the first half of 4G. That was 4G LTE. And then when VoLTE was introduced, VoLTE is when now you could connect to the internet, remain connected to the internet while talking on the phone. So you can do both at the same time. You'll be connected to the, I mean, you can keep talking on the phone while scrolling your Instagram. So you can do both at the same time. So that basically is what we mean by uh, VoLTE. So VoLTE brought this into a very important update was also now brought in because of VoLTE. So that's why that's the basic difference between the two, between LTE and VoLTE. That LTE is where you only talk or use the internet, and VoLTE both possible simultaneously. So this is basically what we see with case of 4G VoLTE. Then comes 5G. Now with 5G, we are saying that the speed now goes up to 10 Gbps. This again is a very big jump on the previous speed of up to 100 Mbps. Now when it comes to this particular scenario of 5G, again obviously it also supports both voice and data, and of course it will also have voltage in place. Now when it comes to 5G, we see that 5G is now basically increasing its reach. You know that last year it was introduced to India officially, and then from there on, slowly and steadily, the network density is something that we have been increasing. We have been introducing 5G networks to newer areas, newer cities and districts, and slowly and steadily we are improving upon the connectivity of 5G in India. So overall, of course, 5G also uses radio waves or radio frequency. What we expect is that by next year it will have a full range of services available in India. We are still trying to improve upon the 5G connectivity that we have, and it is estimated that in India, or in general, sorry, in the world, 5G will have a space for more than 7 trillion devices connected simultaneously. 7 trillion devices. And then obviously faster speeds, greater coverage, lesser latency, high scalability, these are all these uh, factors or all these advantages that we see with 5G. And for India, it is estimated that we would reach a number of up to 88 million connections by 2025. That is next to next year. So that's why these are some of the basic data with regards to 5G. Now, when it comes to 5G, just understand a basic of how 5G works and some of the important technologies which are behind the scenes in the working of 5G. So these things can become very important for your prelims examination, especially. Now, a question in your mains examination also cannot be ruled out. In case of 5G, especially, what are the advantages of 5G? What do you mean by 5G? What are the various properties of 5G? So, there are so many things that they can ask you. So, that's why, from that perspective, although I would say that primarily this is a prelims based topic, but even if a mains based question comes from here, you shouldn't be surprised. And this is a topic for probably the last 2 3 sessions or last 2 3 years I've been saying that this will be important, and I'm expecting it to come, but it hasn't come yet in the paper. Last year I had said the same thing, that I'm expecting this to come. This year I had said the same thing, that I'm expecting this to come, and I'm saying it again. I'm saying it again, that 2024 I'm expecting that a question should come in your prelims or mains examination. So that's why uh, be ready with all the facts and properties and concepts with regards to 5G. Now, in case of 5G, what we basically see is that when it comes to the network connections, it's little different as compared to how 2G, 3G, or 4G connections work. Now, in all these cases of 2G network or 3G or 4G network, what you would find is that there is, let's say, a cell tower, right? There is a cell tower, and this cell tower basically is relaying the information. So, in, let's say, half a kilometer radius or maybe 1 kilometer radius, you have one cell tower, and that provides a connectivity to that area, correct? So, this is basically what we see with 2G, 3G, and 4G. But in case of 5G, we see that the things are a little different. How exactly are they different? That this time you do not really have only a big cell tower, but you also have something which is called as a small cell. 5G small cell. Now, the reason why we need this small cell is that we are not only using the normal frequencies that we have been using until now, we are also using higher frequencies and lower frequencies also. So, to provide this entire range of frequencies, you need more number of towers, smaller number of towers that can connect to a smaller distance. High frequency, high energy, obviously it cannot travel very long, right? This is what we know, because energy dissipation will be very high. So that's why you need small cell towers which can provide connectivity. So in this manner, what happens then is that, let's say if you are talking about an area, suppose that you have a locality where you have all these houses, all right? Let's say you have a locality where all these houses run, and all these houses are, and the roads run, let's say like this. Suppose that the roads are running like this, all right? So if, let's say, the roads are running like this, it means that you need to provide connectivity to this entire area. So now what happens is that for providing connectivity, you need one small cell here. Let's say you have one small cell here, and you have one small cell here. So then what happens is that this one small cell, it will be able to provide connectivity very nicely in these parts. So it will have this much of connectivity, whereas this will be able to connect these kind of areas like this. So, all right, so it will basically be able to connect to all these places. Just me Let me use a different color. So like this, all right? So in this manner, what we'll see is that we'll have to have a higher density of these small cell towers. Higher density of small cell towers will be required, because now you cannot place them for every 1 kilometer and so on. So then in that case, you need higher amount of money, right? Budget allocation has to be higher, because you need so much of infrastructure here. The infrastructure changes and you are adding to the existing infrastructure. So that's why this becomes a challenge. So overall, that's why we see that this kind of a situation will arise with regards to 5G. And you'll see that if you are near these small cell towers, you'll find that your speeds are much better. And that's where right now you might, if at all you are using 5G, you might have seen that 5G speeds are erratic. uh, they sometimes they are wonderful, and there are places where they are not that great. So that depends on how far away or how near a small cell tower you are. If you are in the range of or very close by to a small cell tower, you'll see exceptional speeds. And if you are not, then in that case, you might see normal 4G speeds. So that's basically what we are looking at when it comes to uh, these kind of networks. So let's try to understand some of the basics about the 5G features. So first, it uses higher frequency bands. So until now, we were using only a small part of frequency, but what we basically see is that this time higher frequency bands are also being used in case of 5G, and that also helps us in providing better data. In providing faster data transfer speeds. So that's why we see that these could be used. But these frequencies, obviously, because these are higher frequencies, so they have a shorter range than as compared to the lower frequency band. So something which again goes back to the same basics that we had discussed, that if your frequency is high, energy is high and range will be low. So it will be able, so if you see that 4G was working only in this much of frequency, whereas 5G is working in the entire range of frequency, all right? So that's why the small cell towers are required in case of 5G. Then after that, it also uses the MIMO system that we discussed, multiple input, multiple output. So in this particular scenario, we see that it will allow multiple antennas to be used simultaneously to transmit and receive the signals. And that's why it will be able to improve upon the signal strength. It's not about the speed. Signal strength will be better. I'm not saying that the speeds will be better, because multiple inputs and multiple outputs are being provided, so better connectivity, better signal strengths are being provided. Then after that, there is something called as network slicing that has been introduced as a part of 5G. Now, network slicing means what? When you're cutting something. So something similar is what we are doing with 5G. So with 5G, what we are doing is that we are cutting the entire bandwidth into different bandwidths, so that one kind of service can use one bandwidth. Just look at this figure. That one part of the bandwidth will be used for smartphones, one can be used for automotive, one can be used for internet of things devices. So in this manner we can actually divide this entire network into different slices of network, and that is what we call as network slicing. So that's when network slicing also becomes a very important part of this communication. Then after that, edge computing. So edge computing is also being supported by 5G. Now in this particular scenario, it becomes very crucial, because edge computing also helps us in reducing the latency and improve the application performance. Now what happens is that when it comes to edge computing, what we do in edge computing is that, let's say if there is a central server, this central server will be connected to a large number of smaller localized servers, and these localized servers will be connected to the devices. So this is what we see with edge computing. All right. So what, let's say if edge computing was not being used, then every one of these devices, all the 12 devices that we have here, all these 12 devices would be connected to the central system. So then in that case, network congestion will be higher, and that's why we'll see that the lag in the network will be higher. So that's why latency will be higher. So that's why to reduce that latency, we use edge computing. All right. So edge computing basically will be able to, so I'll just write here that in edge computing, the central server is connected to local servers, and the user is connected to these local servers. This reduces network congestion, improving, or rather decreasing the latency. Decreasing latency. All right. So that's why edge computing becomes crucial. Then there is also OFDMA, something that we had discussed. Now this is again something that will become very crucial, and it will also help in improving upon all these factors that we had discussed in case of 6G also. So here also we see that this will become very crucial. So multiple users will be able to connect to the network simultaneously because of OFDMA without having any issues. Then latency is low, as we discussed, that because of edge computing and other activities that we are doing, we see that latency will be low, and that becomes very crucial. And we see that the latency can be as low as just 1 millisecond. Latency can be as low as just 1 millisecond when it comes to 5G networks. And then lastly, network densification. So what we discussed already is that you need more number of cells, right? We need more number of cells to establish a good 5G network. And that is where we see that network densification also becomes very, very crucial, and it will help in improving upon the signal. It will help in improving upon the signal strength and also the capacity of the network. So that's why there are all these properties. So just know that these are the properties of 5G, and that's why 5G is beneficial. That's why it has all its advantages with its low latency and high speed and all these things. Then there is one thing that is being discussed in the context of India, and this is 5GI. Now, this 5GI is a version of 5G. This is a version of 5G used in, or proposed to be used in India. So this is a version of 5G that is proposed to be used in India, and that is precisely what we are looking at with 5GI. Now in 5GI, we see that overall low band spectrum will be used, and what basically it will be doing is we want to, most importantly, this interoperability with existing networks. What we want is that in some way we should be able to use the existing infrastructure, with regards to the 4G and the 3G cell towers that we have. We need to find a way to use them better even for our 5G connections, because otherwise the total money that we have to spend on getting this network, on establishing 5G networks, would be huge. And this will be a huge burden on all the telecom companies, and also for the fact that when it comes to 5G integration of the entire country, it will take a lot of time if you have to go by the normal procedure of 5G establishment. So for our country, with this kind of expanse and this kind of physiography, is not going to be very easy to provide 5G network to each and every corner of the country unless we come out with some kind of variation. And this is a variation that uh, students at IIT Madras basically had come up with, and they are the ones who had come up with, also uh, went to Government of India, and this is something that India is trying to establish. So this basically will try and use existing 4G and 3G infrastructure. So this is basically what we want with regards to 5GI. So overall, when we look at advantages of 5G, of course, very fast data speeds up to 10 Gbps of speeds is something that we can expect. Ultra low latency, only about up to 1 millisecond. Connectivity for Internet of Things, and we'll discuss about Internet of Things later. Efficient tele-education in agriculture, in manufacturing, in telemedicine, in smart cities and traffic management, in digitization of economy, and improving upon the GDP of the country. So advantages of 5G now go beyond the personal space. The kinds of speed that 5G is able to generate, it's not only going to be useful for personal use, but we'll see that it will be a lot of applications, lot of different kinds of use cases is where 5G will start becoming very crucial. So that's where agriculture, communication, manufacturing, everywhere 5G connections will become crucial. So that's why there will be a lot of advantages that we get with 5G. Now, coming to some of the problems that we have, the issues that we have with 5G, first and foremost, of course, the investment requirements are huge because of the infrastructure, right? Because of the infrastructure requirement and everything that we have to establish, it is going to cost a lot. It is costing a lot. So that's why investment cost requirements are high. Secondly, expensive spectrum. Spectrum basically meaning the frequency. The frequency at which they are going to operate, they are going to be expensive. Why are they expensive? Because you are using more number of or higher number of frequencies. It's just like buying piece of land. All right, it's just like buying piece of land. Because let's say, for example, if you just buy, let's say, 100 square meters of land, or 100 square feet of land, then it might cost you less. If you go and buy 500 square feet of land, it will cost you more. If you go to buy 1500 square feet of land, it will cost you even more. So that's the same scenario here also, that expensive spectrum mainly because more number of higher number of frequencies are to be used here. Then the issue of compatibility of old devices, because older devices, especially the ones that have come in India before 2021, they are not compatible with 5G. They would have only 4G connections available in them. So that's why 4G is only usable there. And if, let's say, somebody wants to use 5G, they'll probably have to go and buy a new device. They'll have to go and buy a new device, which is not ideal, because this also means that you generate a lot of e-waste. Generate a lot of e-waste, lot of electronic waste, because older devices are not compatible. Anyone who wants to now switch to better networks or 5G networks, they'll have to buy a new phone, and that will be a big problem. And there are chances of security and privacy issues as well, which have to be countered better and understood better. So that's why there are certain issues like these that we still have to understand, and we have to find a way. Otherwise, right now what's also happening is that 5G is expensive. 5G is expensive, and that's why for the end user also it will be expensive. So that's why it's all a problem that we have right now. Otherwise, and we have to solve all these problems. Otherwise, the penetration that we are expecting will not happen at that level. And you might have the infrastructure, but people will not go for it unless we start improving it and provide it in a much better manner. Read this question. This was asked in your paper. I'm launching the poll for you. Please mark your answers. All right. So 57% of you have marked D, which actually is the correct answer. Let me discuss this with you. With reference to communication technologies, which is or are the difference or the differences between LTE and VoLTE? First is LTE is commonly marketed as 3G, and VoLTE commonly marketed as advanced 3G. Completely wrong. We discussed that both LTE and VoLTE, they came when? They came in the era of 4G, right? They came in the era of 4G. This is what we discussed, right? They, both of them, they came in the era of 4G. In 3G they were not even there. So that's why there's no concept of VoLTE in 3G. So that's why one is wrong. Second is LTE is data only technology and VoLTE is voice only technology. Is it only technology or over? What we discussed is, now if VoLTE is voice only, it would mean that VoLTE would only let you talk on the phone and not use the internet. But it's the opposite of that. In case of VoLTE, we are saying that you can talk on the phone and use the internet both at the same time. So there is no point of saying, there is no concept of saying that there will be only voice only technology. It is voice over long term evolution. So that's why both are wrong, and correct answer will be neither one nor two. Now it happens. I mean, I understand also that when you have these kind of statements, I mean these kind of questions where both the statements are wrong, uh, our confidence also shakes, that how is it possible that two well constructed statements are both wrong. But it would happen. You have to basically go by the logic of whether this is correct or not based on what you have read, what you have understood. So they do not decide A B C D on the basis of a pattern, that okay, there have been two A's, so now let's give a B, now let's give a C, now let's give a D. No, they'll not do that. There can be 20 A's in one row. Maybe there are all the 20 questions from question number 1 to 20, everything has an answer that is A. So you can't really guarantee that what's going to be A and what's going to be B. So but many times our minds, it starts thinking like that. Our minds would think in this manner, thinking that okay, I've marked 7 or 8 A's, now I should not mark any A. What's the guarantee that all the A's that you have marked are actually correct answers? There's none. So that's why you always have to go by the merit of the question rather than thinking of what should or should not be the correct answer. Read the statement. If you know that the statement is right, good. If you think that the statement is not right, leave it. So depends on what you see in front of you. Right, we are almost done with the time, so let's start from here in tomorrow's class. So internet of things, then blockchain, and then supercomputers and quantum computers. These are the four things that we'll discuss in tomorrow's class. And then after that, the last chapter that we are left with, that is intellectual property rights. So these are the two things that we'll discuss in tomorrow's class. Please remember that on Wednesday we'll have the doubt session. So if you have anything, please keep noting them down, and if it is possible for you, please keep emailing them, so that it makes my job also easier. But it's not that if you want to ask questions there, if you come across any question, you can directly ask those questions in the chat on Wednesday. But otherwise, if possible, please make sure that if you can give the questions in advance. All right, so any question if you have from whatever we discussed in the last 1 hour or so. Leaderboard. Okay. Leaderboard. Yeah, so this is the leaderboard. Good to see a lot of you are giving the correct answers and marking everything correctly. Congratulations to all the leaderboard leaders. Many times I feel that the question paper set by the UPSC is in their own language. I I agree with you. I mean, sometimes just to change the language of what's a commonly known information, they change and make it so complex that it becomes vague. For example, the visible light communication question that we saw, so they also would have known that okay, VLC is used when we want to avoid electromagnetic interference, and what they gave as a statement was that it has no electromagnetic interference, which is not entirely a correct statement. So I know, I agree with you, unfortunately. Please repeat interoperability point. So interoperability means that when you are able to operate in different forms. So for example, when you can use one technology in something else also. So when we can use, for example, in this case, we were talking about 4G and 3G networks, which are pre-existing. So using 3G and 4G networks while designing the 5G network, while designing the 5G infrastructure. So that is what interoperability means. Which topology is used in LAN for most efficient output? This is a purely network communication question, not required for you. What's actually the difference between LTE and VoLTE? See, between LTE and VoLTE, the large, I mean, basically, this is a digital infrastructure, the digital communication infrastructure that has been established in the manner with the help of certain concepts like OFDM, not OFDMA, but rather OFDM. So there is a concept called as OFDM, that is orthogonal frequency division multiplexing. So that multiplexing of the network is done in a manner that will be able to uh, send and receive different types of signals at the same time. So that is what happens in multiplexing. So then it starts building up the difference between LTE and VoLTE. But then there are other things also, and again, these are too technical things to even answer in this question. I mean, in this session. Why are we on flight mode in airplanes? As I told you, that if, let's say, your phones are not on flight mode, then in that case your phones will constantly have an access to radio communication. So radio waves can be transmitted or received by your phone. Now there is a separate radio communication that is also happening between the pilots and wherever they are in contact with on the earth. So so that for their communication to be seamless, we want that any other interference should be stopped. And that's why flight mode, because as soon as you put your phone on flight mode, your phone stops sending or receiving radio signals. Without session timings, and will it be of 3.5 hours? So it depends on the number of doubts and how many questions are being asked. So sometimes these doubt sessions have, I mean, concluded in 1 hour or 1.5 hours. Sometimes it has gone even beyond 3.5 hours. So it depends on what kind of questions and what questions are there. We'll start at the same time. We'll start at 5 o'clock, and depending on how many doubts and what kind of doubts, we'll keep going until the class ends. If flight mode doesn't allow transmission or reception of radio waves, why during flight mode Bluetooth is able to access? Because Bluetooth is a separate, because Bluetooth basically works on a separate infrastructure altogether, although it uses radio waves, but in a very short range, the ultra high frequency radio waves, which will not have any problems with the actual communication, the mobile communication or the wireless communication they are establishing. So that's why Bluetooth still can be used, and that's why the mobile phones even give that functionality, that even if you have put your phone on mobile on your flight mode, even then Bluetooth can be switched on. Otherwise, if there was a chance of interference, the mobile phone companies wouldn't have given you that option at all. So the simple reason is ultra high frequency range, because Bluetooth uses ultra high frequency range, which has a very short range, only 10 meters range. So that's why it will not have any effect on the pilot communication. Why small cell towers have to be placed instead of single tower? The basic reason for that is that if you want to use ultra high frequency, or rather the higher frequencies, then higher frequencies cannot be used, cannot be transmitted to a very large distance. So that's why for those higher frequencies you need smaller towers to be placed all over, so that the short range frequency or short range communication can be established via these small cell towers. Wi-Fi and hotspot have the same intensity? No, not at all. Wi-Fi will be much stronger always as compared to hotspot. Explain edge computing. So edge computing is a kind of computing where instead of every system being connected to the central system will have its data also there in local servers, and the systems will be connected to these local servers. So they will be in the edge of the network, and that's why they are called as edge computing. So it is better and faster, I mean lesser latency and faster speed, because instead of connecting everyone connected to one single network, you have multiple different networks to which it is connected. how I revise these lectures in short time? By understanding. You'll have to go through it a couple of times so that it makes it easier for you to understand, comprehend the concepts. It'll make it easier. Today I'm not in the leaderboard. No problem. Tomorrow is a new day. Those who have no questions can leave. Yes, you can.